Hello there, and welcome to Insightful Vision, where curiosity drifts softly through history and science, takes its time to wonder. Tonight, we're listening for something quieter than the ticking of a clock, deeper than the hum of cities. We're listening for echoes, the kind that comes not from sound, but from time itself, the kind that travels upward through soil and stone, carrying whispers from lives and hands that shaped the world long before our maps began. If you're settling in after a long day, maybe with a warm drink, or just the low glow of a screen keeping you company, I'd like to ask you something. Have you ever wondered how old civilization really is? Not in the way textbooks tell it, with tidy dates and clean categories, but in the way the earth might remember it, as layers, as ruins buried beneath ruins, as memory pressed into rock. Maybe you've stood in front of an ancient monument once, a temple, or a crumbling wall, and felt that odd, quiet tug of recognition, that strange familiarity that whispers, "We've done this before." If you find that kind of wondering as comforting as it is mysterious, I'd be ever so grateful if you gave this little corner of karma a like, maybe subscribed or shared it with someone else who loves the soft edges of science and story. It helps this quiet space reach others who might also enjoy falling asleep with a bit of mystery on their mind. So take a slow breath, loosen your shoulders, and let's begin this journey together. Because somewhere beneath our feet, hidden in the dark and patient earth, there might be the remains of a story that isn't finished yet. When most of us think of civilization, we picture something relatively recent. The fertile valleys of Mesopotamia, the stone temples of Egypt, the ziggurats, the tablets, the beginnings of writing, wheels, cities, and trade. 10,000 years give or take. It feels ancient enough to satisfy curiosity. But the planet itself has been quiet for much longer. It has seen oceans come and go, mountains rise and collapse, continents drift apart like slow-moving clouds. So why in all that time would civilization, that ability to build, to record, to imagine complex systems, appear only once, and so recently? That question has fascinated scientists, historians, and dreamers for centuries. What if we aren't the first? What if before our known history, there were others? Not the kind from myth, not gods or giants, but people or beings who learned how to shape matter, who made tools, who studied the stars. Maybe they were wiped away by a natural disaster. Or maybe by their own doing, leaving behind traces too faint for us to recognize as technology. It sounds like speculation. And in many ways, it is. But it's also an idea that nudges at something very human. The sense that our story might not be the only story written in the dust. Imagine peeling back the layers of Earth as if it were a vast archive, each stratum a chapter of memory. The upper layers are familiar. The remnants of our cities, the plastic, the metal, the evidence of our time. Deeper down, there are older traces. Tools carved from stone, pigments from fires, bones arranged deliberately. But then there's a strange gap, a silence stretching over hundreds of thousands of years. The Earth is very good at recycling itself. Wind, water, tectonic movement, all these things erase. So, what if entire civilizations have simply been folded back into the planet, their stories ground into minerals, their machines turned to dust? In the 1970s, a group of scientists proposed a thought experiment called the Siluran hypothesis. Named after a fictional ancient species from science fiction, it asked a simple question. If an industrial civilization had existed millions of years ago, would we be able to tell? The answer, surprisingly, was uncertain. Most traces of our modern world, our cities, our plastics, even our satellites would not survive intact beyond a few million years. Metals corrode. Concrete turns to dust. Oceans shift, burying coastlines. In the geological record, only the faintest chemical fingerprints might remain. Changes in carbon levels, isotopic anomalies, hints of synthetic compounds that nature doesn't make on her own. It's unsettling to think that an entire civilization could vanish almost without a trace. But it also offers a curious comfort. The earth is resilient. It forgets and renews. It smooths over scars and reshapes memory into something fertile again. And that means, perhaps, that forgetting is part of the planet's rhythm. Still, here and there we find anomalies, artifacts that seem too advanced for their time, structures that appear to defy the known tools of their builders. Most are eventually explained by natural processes or misinterpretation. But not all explanations feel complete. There's a quiet debate that runs beneath archaeology, not always spoken aloud, about how much we truly know. Consider the megalith scattered across continents. Enormous stones cut and placed with precision, so fine that a razor blade can't fit between them. Some weigh hundreds of tons. Yet they were moved without modern cranes or motors. Sites like Baalbek in Lebanon, Sacsayhuaman in Peru, and the Great Pyramids of Giza raise questions not of fantasy, but of practicality. How exactly were they built? We can replicate the work in theory, but the scale and logistics remain staggering. Now imagine one step further. What if some of those feats were not only engineering challenges, but the remnants of knowledge we've lost? Perhaps not machines in the way we imagine, but techniques, materials, or principles that slipped away in a long erosion of time. Ancient technology doesn't need to look like ours. It could be elegant in its simplicity, understanding resonance, geometry, or magnetic alignment in ways that modern science is only beginning to rediscover. Think of the way sound can move matter, grains of sand forming intricate patterns under vibration. Think of how certain stones align perfectly with solstices, how temples channel light or echo at precise frequencies. Maybe what we call superstition or ritual was once the memory of applied science. That's not to say ancient builders had smartphones or engines. It's not about imposing our technology on theirs. It is about recognizing that intelligence takes many forms, and sometimes the most advanced systems are the ones that blend seamlessly with nature, rather than conquering it. If there was once a civilization capable of harnessing energy differently, using sound, magnetism, or biological systems, its remnants might look more like art or geology and circuitry. The technology might not be metal or plastic, but stone, crystal, or something we can't yet interpret. We might have already found it, labeled it as decoration or ritual, and moved on. That's the quiet thrill of this idea. That discovery may not always mean finding something new, but seeing something old in a new light. There's another angle, too. Myths and oral histories from every culture carry stories of ages before our own. Golden ages, great floods, lost cities, beings who taught humanity the arts of civilization. Atlantis, Lemura, Shambhala. Names wrapped in imagination, yet they share an uncanny pattern. The story of knowledge gained, lost, and remembered again. For centuries, scholars dismissed these as allegory, as metaphor. But today, as geology and archaeology grow more precise, some of those stories have gained unexpected context. The end of the last ice age, for instance, brought massive sea level rise, floods, and the submerging of coastal settlements. Entire landscapes vanished. It doesn't take magic to erase a civilization, only water and time. If that happened once, could it have happened more than once? Civilizations could rise in cycles, each leaving faint traces for the next to rediscover. And perhaps that's the pattern we're caught in remembering, rebuilding, relayering in our bones. We might even feel it. That deep ancient familiarity with the act of making when we design machines, carve tools, or align satellites with stars. Maybe we're echoing something that was already known long ago. Evolution doesn't erase curiosity. It carries it forward. What's fascinating is how our technologies, though modern in form, often mirror natural processes. We create networks that resemble neural webs, machines that mimic insects, data systems that evolve like ecosystems. It's possible that any advanced civilization, human or otherwise, would eventually converge on similar solutions, not because of imitation, but because physics itself guides intelligence toward efficiency. That means if ancient technology once existed, it might not look alien at all. It might look familiar. It might even be hiding in plain sight, disguised as ordinary matter or forgotten stone. And that's where this quiet investigation begins, not in conspiracy, but in curiosity. Because the more we learn about deep time, the more we realize how much of our story is missing. Human civilization, as we measure it, is a blink. But the Earth's clock has been ticking for billions of years. Somewhere in that immense timeline, the possibility of others before us, like us, isn't absurd. It's statistically plausible. When you look up at the night sky, you see stars separated by impossible distances. Yet all of them are made of the same elements we find in our bodies, in our buildings, in our breath: carbon, iron, oxygen. The universe repeats itself in patterns. So why wouldn't history do the same? Maybe civilization, like stars, is not a one-time event, but a recurring feature of intelligent life, flaring up, burning bright, and fading into memory, only to return again. And if that's true, then our search for the first civilization isn't just about the past. It's about recognizing the rhythm of creation itself, the way knowledge blooms and withers, the way memory hides in the very materials we walk upon. Perhaps one day, a curious archaeologist in a far future will find the remnants of our world and wonder the same thing we're wondering now. Who were they? How did they live? What were their machines for? And did they too inherit secrets from a civilization even older still? There's a strange symmetry in that thought, a feeling that maybe progress isn't a straight line, but a spiral winding through epochs, repeating themes in new forms. Maybe every civilization carries within it the fossilized memory of the one before. That's where we'll let this thought rest for now, still turning softly like an unearthed deer in the dark as we drift toward the next layer of this mystery. The quiet ancient dawn where civilization first stirred and left its faint fingerprints on the stones. If the first layer of this story lies beneath our feet, then the next one stretches across the horizon where the earliest light of civilization began to rise. The world was different then. Ice still clung to the northern continents. Great plains rolled unbroken for miles, and seas were shallower, their edges extending far beyond today's coastlines. It was a time before nations, before writing, before what we usually call history. And yet, people were already shaping the planet in ways that suggest something more than survival. They were remembering, they were building, they were, in their quiet and practical way, rediscovering how to be human. Archaeologists have long described this era as the Neolithic Revolution, the period when humans shifted from wandering hunter-gatherers to subtle farmers. It sounds simple when summarized that way, as if the transition was sudden, like a switch being turned on somewhere around 10,000 BCE. But when you look closer, that transformation feels far too deliberate to be a simple accident. Agriculture didn't appear randomly across the globe. It emerged in specific regions almost simultaneously on multiple continents, each centered on climates and resources perfectly suited to early experimentation. The pattern is curious. It suggests coordination or memory. In the valleys of the Fertile Crescent along the Tigris-Euphrates, villages were already growing wheat and barley before recorded history began. At the same time, far to the east, rice cultivation was appearing in China, and in the Americas, maize and squash were being domesticated. These aren't identical developments, but they show an underlying logic, as though scattered fragments of older knowledge were resurfacing, reinterpreted by new minds. One of the most striking discoveries from this era lies in the hills of southeastern Turkey at a place called Göbekli. It is a name that still carries a kind of gentle shock among archaeologists, because it doesn't fit the timeline we thought we understood. The site is over 11,000 years old, built before pottery, before metal tools, before permanent cities. Yet standing there are massive stone pillars arranged in circles with precise reliefs of animals, symbols, and abstract patterns. Some of the stones weigh over 10 tons, carved from limestone with tools that by all accounts shouldn't have been capable of such work. The site was deliberately buried after its use, preserved beneath layers of soil for thousands of years. When it was uncovered in the 1990s, it didn't just rewrite a page of archaeology. It quietly erased and redrafted several chapters. The people who built Göbekli were not supposed to exist. Not with that level of sophistication. They weren't city dwellers. They had no metal, no writing, no wheels. Yet they organized labor, designed architecture, and built a ceremonial complex that predates Stonehenge by 6 millennia. The discovery forced scientists to reconsider what civilization really means. We once thought that cities came first and monuments later, that farming led to religion, and that art was a luxury of settled life. But Göbekli suggested the opposite, that a shared spiritual or intellectual drive might have come first, bringing people together, motivating cooperation, and eventually giving rise to agriculture as a necessity to sustain that new way of living. It implies that humanity didn't invent complexity out of nothing. It remembered it. Other clues appear across continents, quiet but persistent. At Jericho, one of the world's oldest continuously inhabited cities, there stands a stone tower more than 30 feet high built around 9000 BCE. It was constructed with precision using a staircase spiraling inside, an architectural feature that seems excessive for a simple farming village. To build such a thing required planning, mathematics, and a concept of public space. It wasn't shelter, it was statement. Further east in the Andes Valley, long before the rise of the later Harappan cities, early settlements were experimenting with standardized bricks, drainage systems, and grided layouts. These features would later reappear thousands of years later in cities like Mohenjo-daro. But the blueprints seem to echo something older still. Patterns repeat like old songs half remembered. And then there are the tools. Around the world, archaeologists have found stone artifacts that seem oddly advanced for their supposed period. Perfectly symmetrical spheres from South Africa dated to over 2 million years ago. Grooved and polished stones in Central America, whose function remains uncertain. Bored holes drilled with such precision that even modern equipment would struggle to replicate them without the right materials. Most of these findings can be explained by nature or coincidence, but every so often, one resists classification. It simply sits there in a display case labeled unknown purpose and quietly refuses to fit the story. That in itself is telling. Human history as we know, it is pieced together from fragments. A pot here, a bone there, a wall, a footprint, a carving. We fill in the gaps with logic, with assumptions, and with the limited view that our current tools provide. But what if the pattern is incomplete because we're missing not just data, but an entire layer of memory? What if there were cultures before the ones we call the first, and their fingerprints are scattered across the archaeological record like faint echoes? Geologists sometimes find layers of sediment that show sudden unexplained disturbances, traces of flood, fire, or upheaval. Around 12,800 years ago, the Earth experienced a period known as the Younger Dryas, a rapid cooling event that may have lasted just over a millennium. Some scientists believe it was triggered by a comet or meteor impact. Others point to oceanic shifts or volcanic activity. Whatever the cause, the climate changed dramatically. Megaporna vanished, glaciers expanded, and many early human settlements disappeared. If there had been a proto-civilization before that event, most of its traces would have been wiped clean. The rising seas that followed would have drowned coastal settlements, which is where early civilizations tend to flourish. Today, over 90% of human population centers lie within 100 kilometers of the sea. Imagine what might lie beneath the continental shelves under hundreds of meters of water. It's not just imagination. Underwater archaeology is beginning to reveal submerged ruins along ancient coastlines, stone roads off the coast of India, terraces and walls beneath Japan's Yonauni Island, remnants of possible structures in the Mediterranean. Most are still debated, But their existence invites one undeniable question. If these are real, how much else is still waiting in silence beneath the sea? Technology doesn't always mean metal and electricity. Sometimes it's knowledge of the environment, of how to align buildings to resist earthquakes, how to cultivate soil without depleting it, and how to use celestial cycles for navigation and agriculture. When ancient builders aligned their monuments with solstices or star risings, it wasn't superstition. It was data encoded in stone. They were measuring the rhythm of the planet with nothing but patience and sky. The first calendars, after all, weren't drawn on paper. They were built into the earth itself. Stone circles in Britain, mounds in North America, temples in Mesoamerica. All of them tracked the movements of sun and moon. The builders may have looked primitive through modern eyes, but they were astronomers in their own right. They saw time as landscape, not as number. And yet there's still something strange about this sudden leap from scattered tribes to monumental architecture. It's as though knowledge appeared faster than it should have. In evolutionary terms, 10,000 years is nothing. The human brain didn't change overnight. Our anatomy has been nearly identical for over 100,000 years. So, why did civilization bloom so abruptly? Maybe because the raw ability was already there, waiting for the right moment, the right conditions, or perhaps the right memory to surface. There's a theory in cultural anthropology called the cognitive revolution, suggesting that sometime around 70,000 years ago, humans developed the ability for complex language, symbolism, and abstract thought. Cave paintings, ornaments, burial rituals all appear around that time. But maybe those weren't inventions either. Maybe they were reawakenings. A species rediscovering what it once knew how to do. If we imagine the timeline of humanity as a long winter interrupted by brief summers of progress, the Forgotten Dawn might have been one of those early springs. A time when communities gathered not just for survival, but for meaning. They looked up at the stars and saw patterns. They felt the turning of the seasons and saw rhythm. They stacked stones, carved figures, sang to the air, not because it was mystical, but because it was logical to them, a way of ordering experience. It's tempting to view ancient people as different from us, as simple or naive. But intelligence doesn't depend on technology. It depends on curiosity. And curiosity, by every measure, is as old as our species. If the builders of Göbekli and Jericho and other early sites had continued uninterrupted, if their knowledge had been preserved instead of scattered by climate and catastrophe, who knows what form civilization might have taken by now? Maybe we'd be the ones unearthing their machines, not the other way around. When scientists study genetic data from modern humans, they sometimes find small puzzling gaps, bottlenecks in population that suggest near-extinction events followed by rapid recovery. It's possible that humanity has faced more collapses than we remember, each one erasing cultural memory, forcing us to rebuild from fragments. What we call prehistory might simply be the silent interval between civilizations, the dark between heartbeats. The evidence we do have, though sparse, points to a remarkable resilience. After every setback, humans reorganized, reimagined, and tried again. The tools became sharper, the structures taller, the questions deeper. It's as though each generation was haunted by an unspoken drive to rebuild something it could almost remember. That is the essence of the Forgotten Dawn. A slow reemergence into awareness. Not the birth of civilization, but its recollection. The old blueprints have buried in collective memory resurfacing as inspiration. When we look at those early monuments, the precision isn't just impressive engineering. It's a signal that intelligence once gained doesn't vanish completely. It sleeps, waiting for hands ready to use it again. As we move forward in time, traces of that rediscovery grow clearer. Villages become towns. Towns become cities. Myths evolve into histories. Stone gives way to metal. And with each advance, humanity steps closer to remembering what it once might have known. The way to measure the world, to channel its forces, to understand the language of its own creations. But for now, in this quiet part of the story, the air is still cool, the light soft, and the people of that early world are just beginning to gather, to build, to carve meaning into the earth again. Their fires flicker against stone, casting the first shadows of architecture. Their eyes turn toward constellations that will one day guide ships and clocks and satellites. They don't know it yet, but they are writing the prologue of everything to come. And somewhere beyond the edge of what we can measure, beyond even our oldest ruins, there may be another layer still waiting. The faint trace of a civilization older than this one, older than memory, older than dawn. The world after that early awakening was full of quiet ambition. People had learned to build, and once that began, it never truly stopped. Across continents, generations carried the knowledge of stacking, carving, and aligning stones. They turned landscapes into memory. Each wall, each monument, each precisely placed slab of rock became a sentence written in a language that time itself would struggle to erase. And while the builders may have vanished, their work remains, whispering across millennia, waiting for us to listen. Stone is patient. It doesn't decay like wood or rust like metal. It endures weather, wind, and neglect. That's why so much of what we know about ancient civilizations comes from stone. It's not that they lacked other materials. It's that the stone remembers. The builders may have used wood, fabric, or metal tools that long ago turned to dust, but the stones they shaped still hold the fingerprints of their minds. Take a moment to imagine the hands that placed those stones. Not the slow, stumbling image of primitive laborers often painted in old textbooks, but engineers, mathematicians, and artists who understood weight, balance, and vibration. The sheer precision of some structures suggests knowledge that goes beyond trial and error. The walls of Sacsayhuaman in Peru, for example, are built from massive stones cut with such accuracy that they interlock perfectly without mortar. The edges are beveled, each piece uniquely shaped, yet fitting together like parts of a puzzle. The result is not only beautiful, but resilient. Those walls have withstood earthquakes that reduced modern buildings to rubble. In Egypt, the pyramids remain the most iconic example of ancient engineering, but familiarity has dulled their mystery. We know they're old. We know they're vast. And yet, it's easy to forget just how extraordinary they are. The Great Pyramid of Giza was built with over 2 million limestone blocks, some weighing as much as 70 tons. Each block was shaped and placed with millimeter-level precision. The structure's alignment with true north is more accurate than many modern buildings achieved with lasers. For centuries, people have proposed explanations ranging from ramps to cranes to unimaginable lost machines. The truth remains debated. What's certain is that whatever technology or organization they used, it worked, and it worked with a consistency that speaks of deep-tested knowledge. Then there are the lesser-known structures scattered in places that don't always make the front pages of archaeology. In the highlands of Bolivia, near Lake Titicaca, lies a site called Pumapunku. Their enormous blocks of andesite stone sit carved into shapes so precise that modern engineers still study their geometry. Some stones feature right angles so sharp that they appear to have been machined. Others fit together in complex interlocking designs that hint at prefabrication. The site is part of the Tiwanaku complex, which flourished long before the Inca. The people who built it left no written records explaining their methods. What remains are stones carved, cut, and arranged with confidence that suggests long familiarity with geometry and tool use. Scientists have tried to replicate the work using copper chisels and stone hammers, and they can produce rough approximations, but the speed and scale at which the original builders worked remains puzzling. Some have speculated that they used lost alloys, advanced abrasives, or even acoustic shaping methods. None of these ideas are proven, but the fact that they reconsidered at all shows how far the craftsmanship exceeds our expectations for its supposed time. Across the world in the jungles of Cambodia, The temples of Angkor whisper a similar story. Constructed centuries later, but reflecting the same impulse, they blend architecture, astronomy, and hydrology into a single vast system. The temples are aligned with celestial events, and their layout mirrors the stars of the constellation Draco. Channels and reservoirs form a hydraulic network that maintains water balance across the region. An ancient form of climate control and irrigation far ahead of its time. While not prehistoric, Angkor represents the continuation of an old pattern. The use of stone not just for shelter or worship, but as a recording medium, an interface between human thought and the natural world. Stone carries another property that is often overlooked: acoustic resonance. Many ancient sites display unusual sound behavior. At Chavín de Huántar in Peru, narrow stone corridors amplify and distort sound, creating deep vibrating tones that researchers believe were intentional. In the Hippo of Hal Saflieni in Malta, a subterranean temple carved from limestone, certain chambers resonate at specific frequencies. A human voice speaking within those walls produces harmonics that can be felt in the chest and skull. Similar effects are found in the temples of Egypt and in megalithic sites in Europe. It raises the possibility that ancient builders understood sound not just as an art, but as a tool. The idea isn't as far-fetched as it sounds. Modern science knows that sound waves can move matter. Resonance can shatter glass, shape metal, and even levitate small objects under controlled conditions. In recent years, physicists have developed acoustic tweezers that use sound to manipulate particles. If we can do this with modern equipment, who is to say that ancient engineers observing the behavior of vibration through stone didn't develop practical uses for it on a different scale? Perhaps they didn't think of it as technology at all, but as an extension of nature's behavior, a principle rather than an invention. There's also evidence that many monuments share a global consistency in their alignment to the stars. The pyramids of Giza align with Orion's belt. The temples of Teotihuacan in Mexico follow the same pattern. Stone circles in Britain and Ireland track the movements of the sun and moon with astonishing accuracy. These alignments aren't accidental. They show a shared concern with the heavens, a desire to connect terrestrial structures with cosmic order. For a civilization emerging from the darkness of prehistory, it suggests not ignorance but awareness, an understanding that time and space are linked, that the sky itself can serve as a clock. When viewed together, these sites begin to form a pattern that crosses oceans and epochs. Different peoples speaking different languages under different skies, built in ways that reflect the same priorities: precision, durability, symmetry, and connection to the stars. The tools may have differed, but the principles seem universal. It's as though an underlying idea, the language of geometry and proportion, was passed down through time, resurfacing wherever humans reached a certain threshold of awareness. That raises another question. How did such ideas travel? Mainstream history teaches that civilizations developed independently, but the similarities between them suggest more interaction than we once thought. Long before recorded trade routes, people were already voyaging across seas. Evidence of transoceanic contact is subtle but growing. In South America, traces of ancient nicotine and cocaine have been found in Egyptian mummies, substances native only to the Americas. In Polynia, ancient chicken DNA matches that of South American breeds. These may not prove global travel, but they hint at an ancient world more connected than we once imagined. If information could travel, even slowly, then so could knowledge. Ideas about architecture, astronomy, and measurement might have spread long before formal writing. Carved stones could act as textbooks, demonstrating principles that words alone couldn't convey. A traveler seeing a monument aligned with the stars might understand its meaning without sharing a language. In that sense, the builders of stone were early scientists, sharing data across continents through geometry and design. The whispers in stone aren't just about technology. They're also about intention. Building something to last thousands of years is an act of faith. It implies a belief in continuity in the future. The people who built these monuments weren't simply marking their existence. They were leaving messages. Some of those messages we can still read. Depictions of animals, constellations, ceremonies. Others are abstract, symbolic, or entirely geometric. They may represent something we no longer have the context to decode. Perhaps maps, instructions, or records written in a visual language that predates our alphabets. A recurring motif found across ancient architecture is the use of the golden ratio or proportions that approximate it. This mathematical relationship appears in nature in shells, flowers, and galaxies, and in the human body. Ancient builders seem drawn to it instinctively, using it to design everything from temple facades to entire city layouts. Whether this was conscious mathematics or an intuitive sense of harmony, it points to an underlying intelligence that saw beauty and structure as inseparable. The act of carving into stone is also an act of preservation. Unlike writing on parchment or clay, inscriptions in stone are nearly immortal. Even when languages vanish, the symbols endure. The Rosetta Stone, for example, survived long enough for modern scholars to unlock ancient Egyptian script. There may be other Rosettas still waiting, buried or eroded, holding translations between worlds we've forgotten. Sometimes the whispers come not from monuments, but from natural formations, altered subtly by human hands. Cut marks on boulders, petroglyphs etched into cliffs, spirals carved into canyon walls. Many of these patterns repeat across continents. Spirals in particular appear in prehistoric art from Ireland to India, from New Mexico to New Zealand. They might represent the sun, cycles of life, or perhaps something deeper. The motion of time itself, the same concept encoded in mathematics and myth alike. Modern science often approaches these mysteries cautiously, wary of overinterpretation. But even within academic circles, there's growing recognition that ancient builders possessed advanced observational skills. They tracked solstices and equinoxes with precision rivaling modern instruments. They predicted eclipses. They understood geometry well enough to construct right angles without modern tools. Their knowledge may have been practical rather than theoretical, but it was no less profound. When you stand before one of these structures, whether a pyramid or a circle of weathered stones on a windswept hill, there's a sense of presence. The stones feel alive in a way that's hard to describe, not in a mystical sense, but as carriers of continuity. They connect you directly to the thoughts of the people who placed them there. Their silence is an emptiness. It's a kind of language, one that speaks slowly across centuries. Some researchers have proposed that the layout of ancient sites forms part of a larger geodetic network, a system of alignments spanning continents, marking points of energy or navigation. While the idea is controversial, the fact remains that many sacred sites share latitude, longitude, or alignment patterns that defy coincidence. Whether intentional or not, the earth itself seems to have guided human construction. Perhaps ancient builders observed natural magnetic lines or followed migratory routes that mirrored planetary geometry. Whatever the case, the consistency is undeniable. In the end, the stones speak not only of mystery, but of memory. Each block, each carving is a fragment of instruction. They tell us that our ancestors were not guessing their way through darkness. They were observing, experimenting, and applying principles that remain valid today. The lost technology may not be machines hidden under the ground, but knowledge. Knowledge of how to work with the world rather than against it. And so the whispers continue. Every excavation, every rediscovered monument, every fragment of carved basalt adds another word to the long conversation between the past and the present. The question isn't whether there was advanced knowledge in the ancient world. The question is how much of it we've already forgotten, and how much we might still remember if we learn to listen again. The journey doesn't end with the stones themselves. They point outward to maps and measurements, to patterns connecting continents, to clues that the builders of old may have charted more than just the stars above. They may have charted the Earth itself. And if that's true, then somewhere among those lines and coordinates lies another secret still waiting to be traced. The stones we've followed so far seem to point outward as if they were part of a larger puzzle spread across the surface of the planet. And indeed, as soon as humans began to measure the world, they began to draw it. The act of mapping is one of the oldest expressions of curiosity we have. It's a way of translating space into understanding, turning terrain into thought. Every map, no matter how simple, is an attempt to make the unknown familiar. But some maps suggest a kind of knowledge that shouldn't have existed when they were drawn. Images of coastlines and continents long before the age of exploration. Features that weren't officially discovered until millennia later. The question of how that could be has haunted cartographers and historians alike for centuries. Because while most ancient maps are symbolic, a few seem almost eerily accurate. They show Antarctica without its ice, the correct proportions of South America, the precise curvature of Earth, long before anyone had the tools to measure it. Some are written on parchment, others carved into stone or copied from even older sources that have long since vanished. Taken individually, each could be dismissed as coincidence or creative guesswork, but together they form a pattern, one that suggests the earliest map makers may have inherited knowledge far older than their own civilizations. One of the most famous examples is the Piri Reis map drawn in 1513 by an Ottoman admiral and scholar named Ahmed Muhyiddin Piri. On its surface, it appears to be a beautifully detailed depiction of the Atlantic world, parts of Europe, Africa, and the Americas. But it's what lies at the southern edge that has caused so much debate. There, beneath the curve of South America, is a large landmass resembling the coast of Antarctica. The detail is striking. The shape matches the continent's true outline, not the ice-covered version known today, but the underlying landmass revealed only by modern sonar and satellite mapping. Piri Reis himself claimed he compiled his chart from many older sources, some dating back to the time of Alexander the Great. He wrote that he used 20 charts in Mapundi to create his composite. Historians generally believe these sources included Arabic and possibly ancient Greek maps. But where did those in turn come from? The level of geographic precision, particularly in latitude, would have required instruments or observations not known to have existed in 1513, let alone in antiquity. Skeptics argue that the resemblance to Antarctica is exaggerated, or that the coastline could simply represent South America extended too far south. But when researchers compared the contours of the Piri Reis map to modern data, they found a match along the Queen More land coast that's difficult to explain as chance. If true, it would imply that someone mapped that region when it was free of ice, which would mean tens of thousands of years ago. Geological studies show that Antarctica's coastline may have been ice-free roughly 6,000 to 12,000 years ago, during a brief warm interval at the end of the last ice age. That falls right within the window when the forgotten dawn was still unfolding. The Piri Reis map isn't the only one that raises questions. The Orontius Phaeus map, published in 1531, also shows a largely ice-free Antarctic continent with mountain ranges and rivers flowing toward the sea. The Watcher map from 1737 depicts similar features, and even includes a division of Antarctica into two land masses separated by a strait, a detail confirmed by seismic studies centuries later. These parallels hint that the information was copied from even older charts, possibly tracing back to a source we've never found. To most historians, this isn't evidence of a lost civilization, but of a long and complex chain of knowledge preservation. They suggest that ancient sailors may have mapped the world gradually, their work passed down through generations, recopied and reinterpreted. But even that explanation leaves gaps. Early maritime cultures, as far as we know, lacked both the ships and the instruments to travel such vast distances, especially through polar regions. The oceans are merciless, and navigation without precise tools is unforgiving. Yet the maps exist, and their detail suggests global awareness long before global travel was thought possible. There's another layer to the mystery. Many ancient maps show the Earth as spherical, not flat. This alone might not seem surprising today, but in the eras before modern astronomy, such precision required more than speculation. Accurately depicting latitude and curvature demands understanding of geometry, trigonometry, and celestial navigation. The Greeks had some of this knowledge, but even their calculations, such as those of Eratosthenes, were built on observations that must have taken centuries of data collection. Could that data have been inherited rather than discovered from scratch? The possibility grows when we consider other artifacts. The anti-mechanism found in a shipwreck off the coast of Greece dates to around 100 BCE and functions as an intricate analog computer capable of predicting eclipses and planetary movements. Its gears are cut with precision, so fine that similar complexity would not appear again until the 18th century. If such a device could exist unnoticed in the ancient world, then advanced methods of celestial measurement might have existed earlier than we assume. The anti-mechanism, in a sense, is a map not of geography, but of time and space. It tracks cycles, coordinates, and alignments with mechanical accuracy. That combination of astronomy and engineering could easily have produced geographic maps of equal sophistication. It's possible then that early topographers didn't need to sail everywhere they depicted. They could have calculated positions using astronomical data, triangulating from the stars, much like modern satellites do with light. Knowledge of Earth's curvature combined with accurate timekeeping could yield remarkable precision. But to achieve that, they would have needed instruments, devices to measure angles, distances, and time with stability far beyond the simple gnomons and sundials we associate with early civilizations. None have survived. But absence of evidence isn't evidence of absence. Most materials decay, especially metals and wood, exposed to centuries of humidity and heat. The tools of those ancient mapmakers could easily have vanished, leaving only the drawings behind. There's another category of maps, though less famous, that complicates things even further. Those carved directly into stone. Petroglyphs and engravings around the world sometimes resemble topographic diagrams with lines and contours that match natural features. Some show river systems or mountain ranges, recognizable from aerial views. The carvings at Valca Monica in Italy, for instance, depict branching lines that some researchers interpret as irrigation or transport routes. Others see them as symbolic. In South America, at sites like Saipad and Nazca, geoglyphs stretch across desert plains for kilometers. Massive figures and lines visible only from above. Whether these were ritual, navigational, or astronomical, they show an understanding of large-scale spatial planning that implies either flight or extensive surveying. How could ancient people have achieved such accuracy without aerial perspective? Some suggest they used high vantage points or scaled models. Others propose that they projected patterns from the stars onto the ground using constellations as templates. Both explanations are plausible, but the effect remains uncanny. The Nazca lines, for example, align with solstices and certain star positions, but they also form complex geometric patterns, spirals, trapezoids, and straight lines that stretch perfectly level for miles. When surveyed with modern instruments, the errors are negligible. To maintain that precision without modern equipment would have required surveying techniques far beyond simple rope and stake methods. The same curiosity extends to early world maps, carved on tablets like the Babylonian Imago Mundi, dated to the 6th century BCE. It portrays a circular world surrounded by water, with cities and regions placed in recognizable relation. While simplistic by modern standards, it shows a concept of Earth as a unified whole. In China, ancient maps from the Warring States period display accurate distances between cities measured in a coordinate grid. And in the Americas, the Aztec codices depict territories, roads, and landmarks with mathematical consistency. These cultures, separated by oceans, each arrived at systematic mapping, suggesting that spatial intelligence is universal, not dependent on contact. Still, what if the earliest of these maps, the ones hinting at pre-ice age geography, aren't original inventions at all, but copies of something older? Imagine a civilization existing during the last warm period, perhaps coastal, with access to seafaring and an obsession with measurement. They might have charted coastlines that no longer exist, islands now submerged, rivers since dried. When their world ended, fragments of their charts could have survived in oral tradition, carved symbols or trade routes. Later societies rediscovering them could have incorporated those fragments into their own maps, blending myth with memory until the original source was forgotten. This concept, known in some circles as geomythology, proposes that ancient legends and depictions of the world may preserve distorted records of real landscapes. Myths of flooded lands, vanished islands, or mountains that once walked might correspond to geological events witnessed by early observers. Over generations, such memories become stories. Atlantis, M.W., a great flood, but the foundation may be factual. If those storytellers also left diagrams or carvings, the line between myth and map becomes difficult to draw. When we look at the maps themselves, we see not just geography, but confidence. The belief that the world can be measured and understood. That belief is the root of science. To chart a coastline is to claim a kind of relationship with it, an acknowledgement that nature has patterns, and that those patterns can be recorded. Whoever the first map makers were, they weren't dreamers sketching guesses. They were observers calculating positions, noting stars, tracking currents. Their technology might have been simple, but their minds were methodical. What's fascinating is that even today with satellites and GPS, our maps are still incomplete. We've mapped less than a quarter of the ocean floor in high resolution. Vast regions remain unexplored, particularly in the deep trenches and under ice. It is humbling to realize that in some ways our ancient predecessors may have known coastlines we've yet to fully rediscover. If there was indeed a lost source behind those impossible maps, what form might it have taken? Perhaps it wasn't a parchment or a globe, but a network, a shared system of observation across distant peoples. Imagine coastal observers marking positions of the sun and stars, sharing data through trade or migration, slowly piecing together a model of Earth over centuries. Such a collaboration wouldn't require modern communication, only persistence and the recognition that the same sky connects everyone. That's the real genius of ancient mapping. It's both local and universal. It begins with a single footprint and ends with an understanding of the planet itself. And yet, some anomalies go beyond even that. Under the ice of Antarctica, radar imaging has revealed structures that appear geometric straight lines, grid-like formations, though most are likely natural. Still, the possibility that remnants of human or pre-human activity lie buried there continues to draw attention. If Antarctica was once habitable, then any civilization living along its coast could have left traces now entombed in ice. The maps showing an ice-free Antarctica could be memories of that lost geography, preserved not by accident, but by design. In the end, what makes these ancient maps so compelling isn't just their mystery, it's their precision. They remind us that knowledge isn't linear. It can appear, vanish, and reappear, carried by memory rather than machines. Our ancestors may not have had satellites, but they had patience, observation, and the sky. They may not have called it science, but the principle was the same. To measure, to understand, to find our place within a vast and shifting world. And somewhere in a library, long turned to dust, or in carvings still hidden beneath sand and sea, there may be one more map, older than any we've seen, drawn by hands that understood the Earth in ways we've only begun to rediscover. Perhaps it's waiting for the right moment to be found again. Its lines and symbols still whisper that long before us, someone else had already drawn the world. Beyond those old charts, beyond the edges of paper and stone, lies another kind of mapping. One that deals not with coastlines, but with energy, sound, and the hidden forces that shape the monuments themselves. And it's there, in that strange border between physics and history, that the next part of this story begins. The idea of a map that outlasts its makers is humbling. But perhaps even more extraordinary is the thought that what they mapped was not only the surface of the earth, but the forces moving through it. The ancients may not have described their work in the language of physics or energy fields, but many of their structures seem to interact with the planet in ways that go beyond shelter or ceremony. They appear to respond to sound, to light, to magnetism. It's as if some builders understood that the earth itself was an engine, a living system that could be tuned, not conquered. When archaeologists talk about lost technology, most people picture machines, metal, ears, engines, maybe something glowing or humming with power. But technology doesn't have to look mechanical. In its simplest form, it's the application of knowledge to achieve a consistent result. If you can control light, sound, or pressure with purpose, that's technology. And much of what ancient builders achieved hints at an understanding of natural forces that feels startlingly advanced. The Great Pyramid is the most famous example, not just for its size or precision, but for the subtle anomalies it presents. Deep within its chambers, measurements show slight electromagnetic differences between layers, with certain stones exhibiting conductive properties. The inner passages are cut in ways that focus sound, creating resonant frequencies that can vibrate the air and stone together. Some researchers have suggested that the shape itself, the pyramid form, might interact with the Earth's natural electric field, concentrating energy in predictable ways. These ideas were once dismissed as pseudotions, but recent studies in material science and acoustics have given them new credibility. The limestone casing of the pyramids, for instance, is a natural insulator, while the granite inside contains quartz and other conductive minerals. When sound waves or vibrations move through such materials, they can produce measurable electrical effects through piezoelectricity. The same principle is used in some modern sensors and lighter ignitions. If ancient builders noticed this behavior even empirically, they might have used it intentionally. Perhaps not to generate electricity in the way we do, but to manipulate resonance, to create stability, or even to amplify ritual sound. The same attention to material appears at other sites. In Malta's Hippo, the limestone walls resonate at precisely 110 Hz, a frequency that affects the human brain, altering perception and emotion. The chambers seem designed for it. Voices deepen, overlapping harmonics ripple through the air. It's not the product of random carving. Someone tuned that space. At Tiwanaku and Puma Punku, the stones are cut from andite and diorite, materials harder than steel. Modern engineers require diamond tip tools to shape them cleanly. Yet these blocks show perfectly smooth surfaces, tight-fitting joints, and parallel grooves as if machined. If their makers used only copper chisels and pounding stones, as conventional explanations hold, the process would have taken generations, and yet entire complexes were built. It suggests either a lost tool or a lost technique. Perhaps something based on vibration, abrasion, or thermal fracturing. There are faint clues in ancient art that vibration might have been more than a metaphor. Depictions of tuning forks, rods, and objects resembling resonators appear in various cultures. Egyptian reliefs show priests holding what look like forked instruments near temple walls. In Sumerian carvings, deities are sometimes shown surrounded by wave-like patterns emanating from rods or discs. These could be symbolic, but they're strangely consistent across regions. If they represent an understanding of resonance, of how energy travels through matter, then they might record a real form of experimentation. Modern experiments with sound levitation show that acoustic standing waves can suspend small particles or droplets in midair, increase the scale, and the effect becomes visible with larger objects. Some researchers have speculated that ancient builders might have used resonance to reduce friction or shift weight when moving massive stones. It sounds improbable, but consider that sound carries energy. With the right frequency, amplitude, and environment, it could have practical effects. Even if not levitation, it might have allowed the manipulation of materials, loosening molecular bonds, softening surfaces, or creating vibration-assisted movement. Another possibility involves magnetism. Many ancient sites are built on or near natural magnetic anomalies. The Great Pyramid, Stonehenge, Machu Picchu, and Teotihuacan all sit along lines of geomagnetic significance. Some align with what are now called Turric currents, slow electrical flows within the Earth's crust. Modern power grids experience these same currents during solar storms. It's conceivable that early builders sensed these effects through observation. Compasses didn't exist, but lodestone does. Magnetized stones could reveal orientation, and electrical discharges during storms might have inspired experimentation. Aligning structures with these currents could stabilize construction or create subtle energetic effects. Even today, modern architecture occasionally rediscovers similar principles. Buildings with certain shapes reduce wind resistance, channel sound, or distribute stress efficiently. Ancient builders observing without theory could have reached the same conclusions through practice. Over generations, those observations could have become tradition, and ritual, then myth, a technology hidden within symbolism. Some patterns in construction seem almost too global to be coincidence. Pyramids appear in Egypt, Sudan, Mexico, Indonesia, and China. Step pyramids, smooth-sided pyramids, terrace ziggurats, different materials, same geometry. The design isn't arbitrary. It distributes weight evenly and maintains structural integrity while reaching upward. But it also mirrors natural energy forms, mountains, waves, even the dispersion of particles in electric fields. The pyramid is efficient because nature itself favors the shape. Perhaps the builders didn't just imitate it, they recognized it. Temples and monuments also share a fascination with orientation. Almost all major complexes are aligned to cardinal directions, solstices, or specific stars. This wasn't decorative. Alignment affects how light enters a space, how heat is distributed, and even how sound behaves. In some temples, morning sunlight penetrates a chamber for only a few days each year, marking time more precisely than any calendar. In others, moonlight or starlight illuminates carving's position to track celestial cycles. The combination of geometry and astronomy creates what we might call environmental machines, structures that interact with the world to measure and express its rhythms. In South America, the ancient Nazca and Paracas cultures carved channels and terraces that managed water flow with extraordinary precision. Their systems balanced pressure and prevented erosion even in desert conditions. In the Andes, the Inca built agricultural terraces so finely graded that each level created a different microclimate, allowing crops from multiple ecosystems to grow in a single valley. These weren't accidental byproducts of necessity. They were applications of engineering, engines of earth and air working in harmony with the environment. On the opposite side of the world in ancient China, builders incorporated resonant bronze vessels known as jing, tuned to specific notes. These weren't only musical instruments. They also served as calibration tools for architecture. The resonance of a hall or bridge could be adjusted by changing its proportions until the structure itself sang in harmony with the intended tone. This practice links acoustics directly to stability, a concept echoed thousands of miles away in the stone temples of India, where vibration was seen as both sacred and structural. One of the most fascinating examples of environmental design is found in the Mayan city of Chichen Itza. When you clap your hands in front of the temple of Kukulkan, the echo doesn't return as a simple reflection. It transforms into a chirping sound closely resembling the call of the quetzal bird, a species sacred to the Mir. The pyramid steps in geometry act as a sound filter, transforming noise into melody. Whether intentional or not, the effect demonstrates an understanding of how structure can shape perception. The builders didn't need digital processes. They had stone and proportion. Ancient builders also seemed aware of energy in more subtle forms. Many megalithic sites are constructed with alternating types of stone, one conductive, one not. This pairing could create localized electric potentials through temperature or stress differences, a natural form of battery. Experiments on dolmens and standing stones show small voltage differences between upright and capstone, particularly after rainfall or during changes in humidity. The effect is weak but measurable. It might have been accidental, or it might have been observed and incorporated intentionally. There are legends in many cultures describing singing stones or talking walls, rocks that hum, ring, or vibrate when struck. Geologists have confirmed that some stones, especially quartz ones, resonate oddly under pressure. If early builders discovered this property, they could have chosen materials based on sound rather than color or weight. A temple that hums when the wind passes through its corridors isn't mystical. It's an early experiment in resonance. The combination of sound, stone, and energy might explain why so many ancient sites feel charged, even to modern visitors. The geometry interacts with natural fields, creating subtle vibrations perceptible through touch and hearing. Modern instruments detect infrasonic frequencies at many megalithic locations. Tones too low for conscious hearing, but capable of influencing mood and physiology. Some frequencies around 7 to 8 Hz correspond to the Schumann resonance, the Earth's natural electromagnetic heartbeat. Perhaps ancient builders tuned their monuments to those frequencies, intentionally creating harmony between structure and planet. If that sounds speculative, consider how modern technology often rediscovers ancient principles. Solar panels capture light, turbines capture wind, hydroelectric dams channel flow. All are refinements of the same idea, using what already exists rather than forcing new power. The ancients may have pursued similar goals using different tools. Their engines were not of steel and combustion, but of stone, sound, and sun. Of course, no direct evidence remains of machines or devices that harness these effects in the way we understand energy. What remains are the results, structures that have survived for thousands of years, often in seismic zones, perfectly balanced, and still functioning as observatories, calendars, and amplifiers. That endurance might be the truest sign of engineering intelligence. What's most remarkable about these ancient engines is that they bridge two worlds, the physical and the perceptual. They are machines of experience, shaping how people felt, heard, and understood their surroundings. Whether used for ceremony, communication, or measurement, they reveal a grasp of principles that modern science only later defined. Frequency, resonance, magnetism, acoustics, optics. The builders didn't need equations to apply them. They simply observed nature long enough to cooperate with it. Some scientists have begun to revisit these possibilities with open minds, using modern equipment to test old hypotheses. Acoustic mapping of stone chambers shows consistent patterns that amplify low-frequency sound. Magnetometers detect fluctuations near certain monuments that coincide with underground structures or metallic veins. Even the microclimates around ancient terraces show engineered stability. Slowly, the line between mythic technology and empirical engineering begins to blur. And perhaps that's the lesson hidden in all this. That technology at its root is observation made repeatable. The ancients may not have left behind engines in the sense of pistons and gears, but they left systems that still function, powered by the same forces we study today. As we follow these traces further, we start to notice how many of these ancient feats are preserved not in materials, but in stories, legends of sound, light, and sky. Tales of gods who taught people to build, of voices that moved stone, of knowledge passed down from an earlier world. Those stories might not describe magic at all, but memory, a way of preserving fragments of science through myth. And those myths, like the monuments themselves, have a strange persistence. They travel across generations, carrying instructions hidden in narrative form, waiting to be rediscovered. Sound is one of the first things every living creature learns to recognize. It's vibration, pressure, information, and comfort all at once. Long before people built tools or cities, they listened. They could hear the wind change before a storm, the hollow tone of a cave that promised shelter, the rhythm of footsteps that meant danger or company. Sound guided survival. But over time, it became something else. A bridge between thought and matter. Somewhere along the line, humans discovered that vibration could do more than communicate. It could shape, organize, and even transform the world around them. If you strike a surface, you don't just make a noise. You create a pattern. That pattern travels through air and material, altering both. Ancient builders might not have described this as physics, but they noticed its effects. When they chanted inside stone chambers, when drums rolled across valleys, when flutes echoed in ritual caves, the vibrations changed their perception of space. It's possible that sound to them wasn't only an expression, but a form of control. A tool as real as any hammer or chisel. Modern science has begun to catch up with that understanding. In laboratories, sound can lift objects, shape sand into complex forms, and even manipulate cells. When a surface vibrates at specific frequencies, particles arrange themselves into precise geometric shapes, a phenomenon called cymatics. These patterns resemble mandalas, lattice structures, even architectural motifs. Ancient carvings often reproduce similar forms, circles, intersecting waves, spirals. Perhaps not as decoration, but as diagrams of what they saw when sound met. The possibility that sound could once have been used as a construction aid is difficult to prove, but it's easy to imagine. Imagine a group of builders discovering that certain tones cause sand to jump, dust to settle, or stone to hum. The observation alone could lead to experimentation. Over time, they might have learned which sound softened a surface, loosened a boulder, or calmed a crowd. They wouldn't have needed words like frequency or resonance. They would have called it the language of the world. There are traces of this understanding scattered through the past. In Egypt, hieroglyphs often depict musical instruments beside symbols of creation. The god Thoth, associated with knowledge and measurement, is sometimes shown with a tuning fork-like staff. The act of speaking creation into being, a theme repeated in multiple cultures, may reflect this link between sound and manifestation. In Mesopotamian myths, the universe is ordered through tone and word. In Vedic traditions, sound is described as the first principle, vibration as the origin of reality. In Greece, Pythagoras taught that numbers and harmonics governed all existence, that music and mathematics were two ways of reading the same code. It's tempting to interpret these ideas symbolically, but they might have had a practical basis. If you understand that sound affects structure, then tuning becomes a form of engineering. The shape of a temple, the dimensions of a chamber, the spacing of columns, all could be designed to enhance or suppress particular frequencies. This would explain why ancient architects paid such attention to proportion. The ratios used in temples across Greece, Egypt, and India correspond to musical intervals, octaves, fifths, fourths. Those intervals aren't arbitrary. They reflect the simplest whole number relationships in physics. They produce harmony because they minimize interference. The ancients may have learned through centuries of trial that buildings built on harmonic ratios were not only beautiful, but stable and resonant. Some ancient sites still demonstrate this effect. In the temples of Luxor, the low chant can echo for many seconds, amplified by walls that seem to breathe with the voice. At the oracle chamber in Delphi, sound focuses toward a single point, magnifying whispers. In Central America, stepped pyramids reflect hand claps as chirps. The same acoustic illusion found at Chichen Itzar. These are not accidents. They're examples of applied acoustics. Architecture tuned like an instrument. Across the world, sound was also used in medicine. Tibetan singing bowls, Aboriginal digitos, African drums, and ancient flutes all employ low frequencies that influence heartbeat, breathing, and mood. Modern studies show that such tones stimulate the vagus nerve and balance brain wave patterns, producing calm or focus. To ancient healers, this wasn't a metaphor. It was technology. They didn't use electrical devices, but they achieved similar outcomes through resonance. There are legends that push this concept further. Stories of priests who could move stones with song, or armies who used sound to disable opponents. Most are treated as myth, but they may be exaggerated memories of real techniques. In the 1930s, explorers in Tibet reported monks using horns and drums to levitate stones during construction. No evidence survives beyond their journals, and most scientists regard the claims as apocryphal. Yet, the idea persists because it fits within a larger pattern. Ancient fascination with vibration as a force. Archaeology offers subtle confirmations. At megalithic sites in Britain, researchers have recorded low-frequency vibrations around certain stone arrangements. When wind passes through gaps or cavities, the tones fall within the same range that affects human emotion and perception. Visitors often describe sensations of pressure or vertigo, which could result from infrasound, vibrations below the threshold of hearing, whether intentional or coincidental. The builders clearly chose shapes and positions that amplify natural resonance. It's not hard to see why sound became sacred. It's invisible yet powerful, temporary yet transformative. It can shape emotion, memory, and matter all at once. Ancient people may have used it to encode information as well. Oral traditions depend on rhythm and repetition to preserve knowledge. The cadence of recitation acts like data compression, ensuring that long history survives through generations. Even today, the oldest surviving texts are poems and songs. The Rig Veda, the Iliad, the Epic of Gilgamesh each began as sound. Perhaps the most sophisticated use of sound in antiquity wasn't musical or structural, but linguistic. The invention of writing often overshadows the technology of speech itself. Yet, spoken language is an engineering marvel. It converts breath into meaning using vibration and pattern recognition. The earlier scripts may have evolved as visual transcriptions of sound, attempts to stabilize knowledge that had long existed in rhythmic form. When writing appeared, it wasn't the birth of communication. It was the solidification of it, like crystallizing a tone into shape. There's another dimension to consider: memory. Before recording devices, memory was the only way to store sound. Cultures developed mnemonic systems based on rhythm, rhyme, and pitch. Aboriginal songlines, for example, encode geography and survival data into melody. By syncing a route, one could navigate hundreds of miles. The landscape itself became a score. In this way, sound became both map and archive, a living database transmitted through performance. The idea that sound could organize knowledge this way isn't unique to one culture. The Polynesians used chants to memorize ocean currents. Africans recited genealogies stretching back centuries. The Druids of Europe maintained oral libraries of law and astronomy. These weren't mystical talents. They were structured systems, optimized memory technologies built from rhythm and tone. In a sense, they were early computers storing and retrieving data through voice. If we look at sound as information storage, then ancient instruments might have served as recording devices of a sort. The vibration of strings, air columns, and membranes encode frequencies that can reflect mathematical ratios, planetary cycles, or calendar data. A drum beat pattern could measure time. A chant could mirror astronomical movement. The recurring correlation between music and cosmology in ancient cultures begins to make more sense. The universe was a score, and humans were both the players and the audience. That understanding survived in fragments. In the Middle Ages, cathedral builders used the same harmonic ratios as Greek temples. The great Gothic halls of Europe resonate at specific frequencies designed to support Gregorian chant. The architects may not have consciously continued in ancient tradition, but the principles were the same. Structure tuned to sound, sound tuned to mind. The effect is undeniable. Step into one of those cathedrals and speak a single note. It returns multiplied, enveloping, as if the air itself is participating in the conversation. In recent years, scientists have explored how sound affects matter at microscopic scales. Experiments in acoustic levitation, sonoluminescence, and vibrational therapy all demonstrate that vibration can influence both physical and biological systems. Bubbles of water collapse with flashes of light when exposed to ultrasound. Cancer cells respond differently to specific frequencies. In liquids, sound can form standing patterns that resemble cellular structures. It is difficult not to wonder if ancient observers lacking microscopes, but rich in patience, notice similar effects at larger scales. Patterns in dust, water, or sand responding to voice or instrument. Perhaps what they saw led them to conclude that the universe itself behaves like a vast resonator tuned across scales. Planets orbit like notes in a chord. Atoms vibrate at specific frequencies. Hearts beat in rhythm with breath. The ancients might have expressed this unity through myth, but the underlying principle that vibration links everything is not wrong. Even now our technology is built on sound in invisible forms. Ultrasound imaging maps bodies through vibration. Sonar charts the ocean floor. Radio waves, technically frequencies far below light, carry voices and data across space. Every communication system from telephones to spacecraft is an evolution of acoustic thinking. We've digitized vibration, but we haven't changed its essence. The knowledge that began with a drum beat or a chant still drives our most advanced machines. What's curious is how little we notice this continuity. We tend to separate the ancient and the modern myth and science, yet the connection is constant. The ancients may have lacked electricity, but they understood resonance. We may have lost their simplicity, but we rediscovered their laws in laboratories. The vocabulary changed, the instruments changed, but the song remained the same. If sound once served as both tool and teacher, it might also have been a way of preserving ideas that couldn't be written down. Certain knowledge may have been passed through frequencies, tones known only to initiates. Encoded patterns that conveyed instruction to those who understood. This isn't fantasy. It's plausible. We already use sound encryption today, embedding data in frequencies beyond normal hearing. The same could have been done millennia ago, intentionally or by accident. Some ancient instruments produce ultrasonic overtones that modern microphones detect, but the human ear cannot. Whether by coincidence or design, the capability existed. As we continue to unearth and study ancient sites, more of these acoustic features come to light. Caves with overlapping echoes that simulate polyphony. Stairways that transform footsteps into melodies. Chambers that sustain a human voice for impossible durations. These effects demonstrate deliberate testing and adjustment. Whoever built those places understood that sound was not just for ceremony. It was a precise science. If you think of civilization as an ongoing conversation between humans and their environment, sound is its earliest dialect. It's how we learn to measure, remember, and connect. The forgotten civilizations may have reached levels of acoustic sophistication that we're only beginning to rediscover. And perhaps that rediscovery is the real purpose of studying them. Not to find lost machines, but to remember that knowledge can exist in any form, even one as fleeting as vibration. When you stand in an ancient temple or among tall stones and feel a subtle hum under your breath, you're hearing more than echo. You're hearing continuity. The same frequencies that once guided the shaping of worlds still move through air, water, and you. The ancients might have called it spirit or harmony, or the voice of the earth. We call it physics. But the difference is only in the language, not the experience. And just beyond that hum, beyond the reach of direct observation, there are stories, myths, and legends that describe gods descending from the sky, bringing knowledge of sound, light, and measurement. Whether those stories are history or metaphor, They suggest a lineage that perhaps the builders didn't invent these sciences, but remembered them. Somewhere in those stories, behind the symbols and the songs, we may find the next trace of that inheritance, waiting quietly to be heard again. Stories have always been our second language. Long before we wrote or recorded anything, we explained the world through narrative. Myths were the first form of science. The earliest data models compressed into symbols and memory. Every culture used them to store what couldn't yet be measured, to make sense of the invisible through images that could be remembered. The result is a vast library of inherited messages, half dream, half observation, waiting to be decoded. When we look closely, these myths are surprisingly consistent. Across continents and centuries, people who have never met describe the same ideas. A great flood that reset the world. Gods descending from the sky to teach civilization. The building of towers or gardens or machines that connected heaven and earth. These aren't just coincidences of imagination. They're signals of shared memory, perhaps carried through migration, trade, or the deep patterns of human psychology. But what if they also preserve traces of real events, ancient lessons or technologies simplified into story so they could survive time itself? Take the story of the Great Flood. It appears in Sumerian, Babylonian, Hebrew, Hindu, Greek, and even Native American traditions. The names change, but the structure remains. The world becomes corrupt or unstable. The waters rise. A chosen few survive to rebuild. On the surface, it's a moral tale about renewal. Yet, geology supports a historical basis. Around 12,000 years ago, melting glaciers caused sea levels to rise dramatically, flooding coastal plains where early civilizations might have thrived. A story that began as a lived experience. Communities watching their world disappear underwater could easily have evolved into myth. Over generations, the details blurred, but the core remained. A civilization lost, knowledge scattered, the survivors charged with remembering. That theme of survival through transmission appears everywhere. In Greek mythology, Prometheus steals fire, a symbol of technology, from the gods and gives it to humans. In Sumerian legends, the Akalu are half-human sages sent from the sea to teach humanity writing, mathematics, and agriculture. In Egypt, Th brings the art of language. In Mesoamerica, Quetzalcoatl arrives from the east to teach astronomy and law. In each case, a divine or semi-divine figure bridges a gap, transferring knowledge from a higher or older realm to a newer one. Maybe these weren't gods in the supernatural sense, but remembered teachers, members of a civilization so advanced that their abilities seemed divine to those who followed. The idea that myths encode historical memory isn't new. Historians often describe them as cultural fossils, fragments of truth preserved within imagination. But what if some myths are more than memory? What if they're instructions? The stories that repeat most often might be those designed to teach something practical: how to measure the sky, when to plant crops, where to build cities. Hidden within symbolic language, these lessons could pass through centuries without being lost to illiteracy or translation. Consider the story of Atlantis recorded by Plato as a memory from an older Egyptian priesthood. It describes a great maritime civilization destroyed by flood and fire around 9,000 years before his time. Scholars have debated it endlessly. Was it fiction, allegory, or history? Plato himself said it was true, though moralized. The description of Atlantis matches no known culture. Yet its details, concentric rings of land and water, advanced engineering, and a sudden cataclysm, mirror geological changes at the end of the Ice Age. If Atlantis wasn't a literal city, it might have been a symbol for all lost coastal civilizations submerged by rising seas. In that case, the story is both myth and report. A message reminding later generations that knowledge can vanish overnight. Similar motifs appear in the Americas. The Aztecs spoke of Aztlan, a luminous homeland across the sea. The Maya preserved legends of its Amna, a bringer of knowledge who came after a great flood. The Hopi tell of previous worlds destroyed by water and fire, each followed by renewal. These stories don't contradict each other. They echo. They may reflect the same collective trauma, remembered through different languages. Even creation myths contain technical hints. In many, the universe begins not with light or substance, but with sound or vibration, a spoken word, a note, a resonance. In the Hebrew Genesis, creation begins with "let there be light," implying sound as the initiating act. In Hindu cosmology, the syllable Om is the vibration from which existence emerges. In Egyptian law, the god Tar speaks the world into being through heart and tongue, uniting intention and sound. These parallels suggest a shared intuition that vibration, the same force explored in ancient architecture and instruments, was the key to creation itself. Whether literal or symbolic, the message is consistent. It is difficult not to wonder if ancient observers lacking microscopes, but rich in patience, notice similar effects at larger scales. Patterns in dust, water, or sand responding to voice or instrument. Perhaps what they saw led them to conclude that the universe itself behaves like a vast resonator tuned across scales. Planets orbit like notes in a chord. Atoms vibrate at specific frequencies. Hearts beat in rhythm with breath. The ancients might have expressed this unity through myth, but the underlying principle that vibration links everything is not wrong. Even now our technology is built on sound in invisible forms. Ultrasound imaging maps bodies through vibration. Sonar charts the ocean floor. Radio waves, technically frequencies far below light, carry voices and data across space. Every communication system from telephones to spacecraft is an evolution of acoustic thinking. We've digitized vibration, but we haven't changed its essence. The knowledge that began with a drum beat or a chant still drives our most advanced machines. What's curious is how little we notice this continuity. We tend to separate the ancient and the modern myth and science, yet the connection is constant. The ancients may have lacked electricity, but they understood resonance. We may have lost their simplicity, but we rediscovered their laws in laboratories. The vocabulary changed, the instruments changed, but the song remained the same. If sound once served as both tool and teacher, it might also have been a way of preserving ideas that couldn't be written down. Certain knowledge may have been passed through frequencies, tones known only to initiates. Encoded patterns that conveyed instruction to those who understood. This isn't fantasy. It's plausible. We already use sound encryption today, embedding data in frequencies beyond normal hearing. The same could have been done millennia ago, intentionally or by accident. Some ancient instruments produce ultrasonic overtones that modern microphones detect, but the human ear cannot. Whether by coincidence or design, the capability existed. As we continue to unearth and study ancient sites, more of these acoustic features come to light. Caves with overlapping echoes that simulate polyphony. Stairways that transform footsteps into melodies. Chambers that sustain a human voice for impossible durations. These effects demonstrate deliberate testing and adjustment. Whoever built those places understood that sound was not just for ceremony. It was a precise science. If you think of civilization as an ongoing conversation between humans and their environment, sound is its earliest dialect. It's how we learn to measure, remember, and connect. The forgotten civilizations may have reached levels of acoustic sophistication that we're only beginning to rediscover. And perhaps that rediscovery is the real purpose of studying them. Not to find lost machines, but to remember that knowledge can exist in any form, even one as fleeting as vibration. When you stand in an ancient temple or among tall stones and feel a subtle hum under your breath, you're hearing more than echo. You're hearing continuity. The same frequencies that once guided the shaping of worlds still move through air, water, and you. The ancients might have called it spirit or harmony, or the voice of the earth. We call it physics. But the difference is only in the language, not the experience. And just beyond that hum, beyond the reach of direct observation, there are stories, myths, and legends that describe gods descending from the sky, bringing knowledge of sound, light, and measurement. Whether those stories are history or metaphor, they suggest a lineage that perhaps the builders didn't invent these sciences, but remembered them. Somewhere in those stories, behind the symbols and the songs, we may find the next trace of that inheritance, waiting quietly to be heard again. Stories have always been our second language. Long before we wrote or recorded anything, we explained the world through narrative. Myths were the first form of science. The earliest data models compressed into symbols and memory. Every culture used them to store what couldn't yet be measured, to make sense of the invisible through images that could be remembered. The result is a vast library of inherited messages, half dream, half observation, waiting to be decoded. When we look closely, these myths are surprisingly consistent. Across continents and centuries, people who have never met describe the same ideas. A great flood that reset the world. Gods descending from the sky to teach civilization. The building of towers or gardens or machines that connected heaven and earth. These aren't just coincidences of imagination. They're signals of shared memory, perhaps carried through migration, trade, or the deep patterns of human psychology. But what if they also preserve traces of real events, ancient lessons or technologies simplified into story so they could survive time itself? Take the story of the Great Flood. It appears in Sumerian, Babylonian, Hebrew, Hindu, Greek, and even Native American traditions. The names change, but the structure remains. The world becomes corrupt or unstable. The waters rise. A chosen few survive to rebuild. On the surface, it's a moral tale about renewal. Yet, geology supports a historical basis. Around 12,000 years ago, melting glaciers caused sea levels to rise dramatically, flooding coastal plains where early civilizations might have thrived. A story that began as a lived experience. Communities watching their world disappear underwater could easily have evolved into myth. Over generations, the details blurred, but the core remained. A civilization lost, knowledge scattered, the survivors charged with remembering. That theme of survival through transmission appears everywhere. In Greek mythology, Prometheus steals fire, a symbol of technology, from the gods and gives it to humans. In Sumerian legends, the Akalu are half-human sages sent from the sea to teach humanity writing, mathematics, and agriculture. In Egypt, Th brings the art of language. In Mesoamerica, Quetzalcoatl arrives from the east to teach astronomy and law. In each case, a divine or semi-divine figure bridges a gap, transferring knowledge from a higher or older realm to a newer one. Maybe these weren't gods in the supernatural sense, but remembered teachers, members of a civilization so advanced that their abilities seemed divine to those who followed. The idea that myths encode historical memory isn't new. Historians often describe them as cultural fossils, fragments of truth preserved within imagination. But what if some myths are more than memory? What if they're instructions? The stories that repeat most often might be those designed to teach something practical: how to measure the sky, when to plant crops, where to build cities. Hidden within symbolic language, these lessons could pass through centuries without being lost to illiteracy or translation. Consider the story of Atlantis recorded by Plato as a memory from an older Egyptian priesthood. It describes a great maritime civilization destroyed by flood and fire around 9,000 years before his time. Scholars have debated it endlessly. Was it fiction, allegory, or history? Plato himself said it was true, though moralized. The description of Atlantis matches no known culture. Yet its details, concentric rings of land and water, advanced engineering, and a sudden cataclysm, mirror geological changes at the end of the Ice Age. If Atlantis wasn't a literal city, It might have been a symbol for all lost coastal civilizations submerged by rising seas. In that case, the story is both myth and report. A message reminding later generations that knowledge can vanish overnight. Similar motifs appear in the Americas. The Aztecs spoke of Aztlan, a luminous homeland across the sea. The Maya preserved legends of its Amna, a bringer of knowledge who came after a great flood. The Hopi tell of previous worlds destroyed by water and fire, each followed by renewal. These stories don't contradict each other. They echo. They may reflect the same collective trauma, remembered through different languages. Even creation myths contain technical hints. In many, the universe begins not with light or substance, but with sound or vibration, a spoken word, a note, a resonance. In the Hebrew Genesis, creation begins with "let there be light," implying sound as the initiating act. In Hindu cosmology, the syllable Om is the vibration from which existence emerges. In Egyptian law, the god Tar speaks the world into being through heart and tongue, uniting intention and sound. These parallels suggest a shared intuition that vibration, the same force explored in ancient architecture and instruments, was the key to creation itself. Whether literal or symbolic, the message is consistent. Sound shapes reality. There's also a recurring fascination with light and flight. Figures descending from the heavens, bringing tools, measuring the land, and departing with promises to return. To modern ears, such stories sound like myths of gods or celestial beings. But they could also describe ancient astronomers, sailors, or scientists whose skills seemed miraculous to less advanced cultures. To map stars accurately, one must understand angles, time, and movement. Knowledge is indistinguishable from magic without instruments. A visitor bearing charts and instruments could easily become mythologized as a messenger from the sky. Sometimes the messages hide in geometry. Sacred symbols like the flower of life, the Sri Yantra, or the labyrinth pattern appear in unrelated cultures separated by oceans. These designs encode mathematical relationships, ratios, symmetries, and fractals. Long before formal notation existed, they might have served as visual mnemonics, teaching geometry through repetition. Their persistence across time suggests that the knowledge they represent was too valuable to lose. So it was embedded in art and ritual instead of text. Language itself preserves these traces. The roots of ancient words for knowledge, light, and sound often overlap. In Greek, phos means both light and understanding. In Sanskrit, vidya means knowledge and is related to seeing. Even the Latin scientia implies not possession, but perception. To know is to see. It's as if ancient thinkers understood that all perception, whether visual or auditory, was a way of decoding the same underlying patterns. Their myths then might be early attempts to express scientific principles through narrative, a storybook written for the pre-iterate world. In that context, myth becomes a kind of encryption. The story of gods forging thunderbolts could represent metallurgy or electricity. Tales of chariots crossing the sky might describe comets, planets, or even atmospheric phenomena. The legend of Icarus could be a warning about overreaching technology, just as the Tower of Babel might symbolize the dangers of misused communication or energy. These stories survive, not because they're entertaining, but because they carry warnings and insights hidden beneath metaphor. One example often cited is the Mahabharata, an ancient Indian epic that describes flying machines called vimanas and weapons, capable of burning entire cities with radiant heat. To a modern reader, these passages sound like science fiction. To a historian, they're mythic exaggerations. Yet the text also contains precise astronomical data, detailed measurements of time, and descriptions of mechanical devices. Even if the vimanas were symbolic, they reveal an imagination steeped in observation, a society aware of flight, combustion, and motion long before such concepts were formalized. The myth may not record a literal war with radiant weapons, but it might preserve the memory of catastrophic fire, volcanic eruptions, meteor impacts, or lost technologies misunderstood by later storytellers. In Mesoamerica, similar imagery appears. The feathered serpent god Quetzalcoatl is often depicted surrounded by flames or radiance, teaching mathematics and astronomy. When he departs, he promises to return on a ship of light. To modern sensibilities, that sounds metaphorical. But to those who witnessed unusual celestial events, comets, auroras, meteors, light itself may have symbolized knowledge descending from the heavens. The connection between light and learning runs deep in human language for a reason. The consistency of these motifs, descent, instruction, catastrophe, renewal, suggests an organized effort to preserve information. Myths may have functioned like data redundancy, ensuring that even if writing, tools, and cities were lost, the essential knowledge would persist in story form. A culture that understands this would embed key ideas in every medium, songs, symbols, rituals, and legends. The myth becomes a delivery system for science. Modern anthropologists sometimes refer to this as cultural coding. Information that can't be written or explained directly is transmitted through metaphor so that it survives reinterpretation. Over time, the surface meaning changes, but the structure, the code remains. That's why flood myths, sky gods, and sacred geometries reappear everywhere. They're the checksum of civilization, verifying that something older is still intact beneath the surface. Of course, myth can also distort. Over generations, context fades. A parable about energy becomes a tale of divine worth. A description of technology becomes a story of magic. Yet even distortion has value. It shows where human memory resisted total erasure. Somewhere within the exaggeration lies a core of truth, not in the supernatural details, but in the persistence of the idea itself. If we approach myth scientifically as data, it becomes another archaeological layer, not of stone, but of language. Comparative mythology, the study of patterns across cultures, often reveals alignments with geological or astronomical events. Solar myths correspond to sunspot cycles. Serpent symbols align with rivers and fault lines. Fire and flood legends cluster around volcanic and glacial transitions. These correlations suggest that myths record environmental data in narrative form. The ancients didn't just watch the world. They logged it in the only durable medium they had, story. And just as fossils reveal extinct species, myths might reveal extinct knowledge. A society that once harnessed resonance, geometry, and natural energy might encode those principles in creation stories to ensure they were never entirely forgotten. Over time, the equations became metaphors. The instruments became symbols, but the message endured. When modern scientists cipher these patterns, they often rediscover what ancient myths already implied. The universe vibrates. Energy and matter interchange. Catastrophes reshape life in cycles. Knowledge can survive destruction if it adapts its form. The ancients didn't predict these truths with mystical insight. They remembered them through story. The more we learn about myth, the more it looks like an early form of encryption, a method for protecting complex knowledge from the fragility of human memory. Perhaps that's the most profound technology the ancients possessed. The ability to turn data into narrative, to hide truth inside story so it could travel through time unbroken. And somewhere within those stories, behind the symbols of fire and water, flight and sound, lies a recurring memory of teachers who came before, of civilizations that rose and fell, of knowledge that survived the flood. If we could translate every symbol, align every myth, we might find that they all point in the same direction toward a shared origin, a forgotten era when science and story were the same language. The next traces of that language might not lie in words at all, but in places. The rumored cities beneath waves and ice. The ruins are buried under sand and soil. To follow the messages left in myth, we have to go deeper to where legend meets geology. And the earth itself holds the next chapter of memory. The stories of the flood, the bringers of knowledge, and the vanished worlds all seem to converge into one great reflection. A mirror we have held up to the past and named Atlantis. The name itself has become a kind of shorthand for every forgotten civilization, every mystery beneath the sea. Yet, when Plato wrote of it more than 2,000 years ago, he described it not as fantasy, but as history. He claimed the story came from Egyptian records older than memory, telling of a great island empire that fell beneath the waves in a single day and night. To him, Atlantis was a warning, a reflection of pride, excess, and loss. To us, it's a symbol of possibility. Atlantis is the mirror we use to ask how much we've forgotten, whether it was real or not. It forces us to look at our own civilization and wonder what traces of ours would remain if the sea rose again, or if time erased our records. If we vanish tomorrow, how long would our cities endure, our satellites, our plastics, our power grids? They would crumble faster than we imagine. In a few thousand years, only faint scars would mark our presence. In 10,000, even those might be gone. The earth forgets quickly, and water is its most efficient eraser. Plato's account places Atlantis beyond the Pillars of Heracles, the Strait of Gibraltar, describing a continent-sized island rich in metal, agriculture, and architecture. Its people were said to have mastered engineering, built canals and temples, and maintained a vast navy. The description is detailed enough to suggest he was drawing from a specific source. Yet no trace has ever been found where he placed it. Some believe it lies beneath the Atlantic, others in the Mediterranean, the Caribbean, or Antarctica. Each theory has its evidence, its anomalies, and its critics. But perhaps the exact location is less important than what the story represents. The idea of civilization as a repeating phenomenon, not a single linear ascent. Geologists and oceanographers have identified numerous sunken plateaus and continental fragments along the ocean floors. Biathos Plateau, for example, rises from the mid-Atlantic ridge and shows evidence of volcanic activity that could have destroyed large land masses in the distant past. The Canary Islands, Madeira, and Cape Verde all bear traces of ancient uplift and collapse. None match Plato's description precisely, but the geography is suggestive. A region where islands could have emerged, flourished, and vanished within the span of human myth. In recent decades, underwater archaeology has revealed that once dry lands now lie submerged beneath the sea. Dogger Land in the North Sea, between Britain and Denmark, was once a vast plain supporting rivers, forests, and people. It disappeared around 8,000 years ago, as sea levels rose off the coast of India near Dwarka and the Gulf of Khat. Divers have found submerged structures resembling walls and streets dated to roughly the same period. In the Mediterranean, ruins near the island of Fera, modern Santorini, show a civilization destroyed by one of the largest volcanic eruptions in recorded history around 1600 B.C.E. These discoveries demonstrate that entire cultures can vanish suddenly and leave only faint traces beneath the waves. The parallels to Atlantis are striking, even if not exact. A powerful society, a sudden catastrophe, a flood. These are patterns repeated in both myth and geology. The story's endurance might reflect collective memory of multiple events combined into one symbol. Perhaps there was no single Atlantis, but many coastal civilizations erased by rising seas, remembered through fragments of story until they merged into one enduring myth. Plato's narrative also carries details that feel technical. He describes a city laid out in concentric rings of land and water, connected by canals with a central temple lined with precious metals. The design reflects fantastical mirrors, hydraulic and astronomical principles. Concentric layouts appear in prehistoric sites like Bessapie and in later structures such as Stonehenge. Circular symmetry allows even distribution of energy and communication, practical for both ritual and urban planning. Whether Plato invented the design or drew it from older sources, it reflects architectural knowledge consistent with advanced engineering. He also describes Atlantis as having power over the surrounding seas, implying navigation, trade, and maritime dominance. The idea of a seafaring global civilization before recorded history might sound improbable, but archaeology continues to find evidence of early ocean travel. Ancient Polynesians navigated thousands of miles using stars and currents. The Egyptians traded across the Red Sea. The Indus Valley Civilization reached Mesopotamia by ship. If even small cultures achieve such distances, a larger coordinated maritime network isn't impossible. It may have existed only to collapse when coastlines changed. Some researchers see traces of Atlanton-like knowledge in scattered artifacts. The similarities between pyramid construction in distant lands, or the shared use of advanced masonry and astronomical alignment, hint at a common heritage. Mainstream science explains these parallels as convergent evolution of ideas. Different cultures discover similar solutions independently, but convergence itself may suggest something deeper, that human intelligence follows consistent patterns when conditions align, and that these conditions might recur after each collapse, producing the same results under new names. Still, Atlantis resonates because it feels personal. It's a reflection of what happens when progress outpaces humility. Plato described its fall as punishment for arrogance, for using knowledge without wisdom. Whether factual or allegorical, the lesson applies to every age. Civilizations often believe their mastery of nature is permanent. Then the climate shifts, the ground moves, or the seas rise, and the illusion fades. Atlantis endures because it captures that cycle perfectly. Creation, pride, destruction, remembrance. In the 20th century, the myth gained new life through speculation. Explorers mapped the ocean floor, searching for its ruins. Writers linked it to lost continents like Lemura or Mu, and mystics claimed psychic contact with its inhabitants. Most of these claims lacked evidence, but they revealed something important: humanity's persistent intuition that our story might be older than we think. Even as technology advances, we keep returning to the same image: a world before ours that knew things we've only begun to rediscover. Interestingly, Plato never described Atlantis as supernatural. Its people were human, descended from gods only in mythic lineage. Their achievements were not magical, but technical. Architecture, metallurgy, agriculture, astronomy. The civilization fell not because of sorcery, but because of imbalance. The same imbalance that can undermine any society when its creations grow faster than its ethics. The moral remains scientific. Knowledge without wisdom destabilizes itself. If we strip away the supernatural layers, the Atlantis story becomes a geological and sociological hypothesis that civilization has cycled before that technology can arise and vanish within the memory of the Earth's climate. This concept aligns with the geological record, showing abrupt transitions with entire ecosystems and possibly cultures erased in centuries. It also aligns with myths worldwide that describe teachers and survivors rebuilding after disaster. Perhaps the most compelling version of Atlantis isn't a single city, but an idea, a mirror held up by history to show us our potential and our fragility. We look into it and see both the heights of human ingenuity and the depths of our forgetfulness. Every skyscraper and satellite is another reflection of that ancient ambition, reaching upward while standing on a foundation that may be far older than we admit. The symbolic value of Atlantis also extends beyond geography. It represents memory itself, the part of human consciousness that stores what we can't quite prove, but can't forget either. When artists, scientists, or philosophers imagine lost golden ages, they're not necessarily fantasizing. They're expressing that deep intuition that knowledge doesn't vanish entirely. It recycles like elements in a star, forming new combinations each time. The mirror of Atlantis might also reflect us forward. If an earlier civilization fell due to environmental change or overreach, we face similar patterns today. Warming seas, shifting climates, the illusion of control. The myth warns that no amount of mastery exempts us from from natural law. It's not prophecy, it's pattern recognition. Yet within the warning lies hope. Every version of the Atlantis story ends not with extinction, but with renewal. Survivors scatter, teaching remnants of knowledge to new cultures. The memory persists, waiting for rediscovery. That persistence itself may be the legacy of Atlantis. Not a lost city, but a continuity of inquiry. The same drive that built canals and temples now builds laboratories and telescopes. The same curiosity that charted stars now explores galaxies. When we think of Atlantis as a legend, we miss the deeper point. It's a model of human behavior encoded in narrative. Civilizations rise through curiosity, flourish through balance, and fall through excess. But even in collapse, they seed the next cycle with fragments of memory. That's why the myth won't fade. It's our collective self-portrait drawn in water and stone. There are hints that ancient people understood this cyclic view of time. Many calendars from the Mayan to the Hindu measure existence in repeating ages rather than linear progression. Each age ends with destruction and renewal. In that sense, Atlantis isn't the past or future. It's one phase of an ongoing cycle. The earth resets, civilizations return, each inheriting what little the last left behind. If we read Plato's account this way, the moral transforms. Atlantis isn't just a warning against arrogance. It's a reassurance that rebirth follows loss. The sea that drowns also preserves. The earth that shakes also creates. The mirror doesn't show only ruin, but resilience. Modern expeditions continue to search for physical evidence. Sonar surveys have mapped anomalies on the ocean floor, ridges and formations that some interpret as artificial, though most prove geological. Yet the persistence of the search matters more than the results. Each new expedition, whether in the Atlantic, the Caribbean, or under Antarctic ice, carries the same question forward. What if the story was true, not literally, but geologically, symbolically, scientifically? What if humanity has been older, wiser, and more cyclical than we think? The mirror invites humility. It reminds us that discovery and loss are part of the same process. Every age believes it stands at the pinnacle of understanding, but the sediment of history shows otherwise. Beneath every modern foundation lies another, buried and forgotten, its stone softened by time. If we could peel back each layer, we might find not just ruins, but recognition. The quiet certainty that we've been here before in different forms, with different tools asking the same questions. In that sense, Atlantis may be less a place than a pattern, a reflection of the eternal dialogue between knowledge and nature. The ancients gave it a name because they needed a story to hold the idea. We inherit the story because we need a reminder that knowledge once gained is never entirely lost. It changes shape, drifts like an island beneath waves, waiting for someone to rediscover it and name it again. And beyond that mirror, beneath the sea and ice, there are places still untouched, where ruins and fossils blur together, and the next clues wait in silence. As we move toward them, following the myths into the deep, we begin to realize that history and geology are not separate disciplines. They're reflections of one another, both tracing the memory of civilizations the earth has folded into itself, preserving their echoes for those willing to listen. Beneath the calm surface of the world, there are layers of silence we have only begun to uncover. Under the shifting deserts and frozen caps, beneath the places we call inhospitable or empty, the earth keeps its deepest archives. It doesn't store history the way we do in words or images, but in temperature, pressure, and sediment. Every grain of sand, every layer of ice, every buried fragment of bone is a line in the planet's own record. And as we've learned to read that record more precisely, it has started to whisper back to us about worlds that came before ours. Deserts and ice sheets seem like opposites. One a furnace of light, the other a frozen night. Yet both share a strange quality, preservation, sand berries and ice seals. What they hide, they also protect. This is why so many of the oldest, most perplexing clues about humanity's past come not from fertile lands or river valleys, but from places that appear lifeless. The dry and the frozen are where time slows down. In the sands of Egypt, discoveries still redefine what we think we know about our ancestors. Entire cities have been found beneath dunes. Their walls are preserved by the very elements that once threatened them. Satellite imaging reveals outlines of buried structures invisible from the ground. Roads, enclosures, even gardens. The desert doesn't erase quickly, it conceals. And the same is true far beyond Egypt. Across North Africa, the Arabian Peninsula, and parts of Central Asia, shifting sands hide older landscapes, riverbeds, lakes, and human footprints from an age when those regions were green. During the last ice age, much of what is now desert was grassland, dotted with rivers and herds. The Sahara itself was once alive with vegetation and lakes, its rock art showing swimmers, elephants, and giraffes. That alone shifts our understanding of where early civilizations could have thrived. If fertile corridors existed, where we now find dunes, they could have supported settlements, trade, and innovation that vanished as the climate changed. Sand swept over villages and temples, burying them until only legends remained. Under the ice, the story is the same, only slower. Antarctica, the coldest and most isolated continent on Earth, was not always a desert of snow. Geological surveys and core samples show that millions of years ago, it was covered in forests. More recently, about 12,000 years ago, parts of its coast may have been ice-free. Beneath its miles-thick glaciers lie mountains, valleys, and river systems mapped by radar in exquisite detail. The landscape beneath resembles other continents, complete with canyons larger than the Grand Canyon and mountain ranges as vast as the Alps. What makes Antarctica so compelling is not just its hidden geography, but the possibility that it might preserve traces of human or pre-human activity. Any structure built there before the ice advanced would now be entombed and perfectly preserved. Ice traps, air, microbes, and even pollen for hundreds of thousands of years. It's a natural time capsule, and with every new radar scan, researchers find shapes that challenge expectations, ridges that look too regular, formations that align like walls, and grid-like anomalies that fuel endless debate. Most are natural, a product of geology and glaciation. But the questions they raise keep attention fixed on the frozen continent. The connection between ice and lost civilization isn't new. In the 20th century, some theorists proposed that the Antarctic ice cap might hide the ruins of a forgotten world. Perhaps even the fabled Atlantis relocated south. While those ideas remain speculative, they reflect an intuition shared by many scientists that our current picture of human history is incomplete because so much of it lies under environments we can't yet explore directly. Ocean floors, glaciers, and deserts cover over 90% of the potential archaeological record. We're studying only the exposed fraction. The same challenge exists beneath the seas. Coastal regions now submerged once hosted early settlements. In the Bay of Kham off India, sonar scans revealed geometric structures buried under hundreds of feet of water, dated by some estimates to 9,000 years ago. Off the coast of Japan near Yonauni, a series of massive stone terraces and steps rise from the ocean floor. Debate continues about whether they're natural formations or human-made. Yet their symmetry and orientation make coincidence difficult to accept. Similar underwater formations appear in the Caribbean, the Mediterranean, and around the Azores. Each discovery expands the map of possibility. Under sand or ice, what we find often doesn't look like technology. It looks like a pattern, too regular to dismiss, but too eroded to define. Straight lines in satellite images, right angles in stone, magnetically distinct areas under glaciers. To the cautious mind, these are geological quirks. To the curious, they're whispers of memory. The truth likely lies between natural features modified or chosen by humans long ago, now reclaimed by nature until only faint geometry remains. Our ability to read these hidden layers is improving. Ground-penetrating radar, LIRE, and ice core analysis now reveal details invisible to the naked eye. In the Amazon, LIRE scanning has uncovered entire cities beneath the forest canopy, showing roads, plazas, and canals larger than any previously known. The same technology applied to deserts has revealed ancient river systems and settlements, thought to have disappeared thousands of years ago. Every scan suggests that what we see on the surface is only a fragment of what once existed in Antarctica. The discovery of subglacial lakes, pockets of liquid water trapped beneath miles of ice, has renewed scientific interest. These lakes are sealed ecosystems isolated from millions of years. Yet, they may also contain geological records of the continent before it froze. If sediments beneath them show evidence of organic material or human activity, it would fundamentally alter our understanding of when and where civilization could have existed. Researchers drill cautiously, aware that contamination could erase delicate clues. Even so, each core sample draws us closer to a time when the ice itself may have been young. The same process unfolds in the deserts, where shifting dunes occasionally expose glimpses of the past. A wall, a fossil, a shard of pottery. These moments remind us that erasure is rarely absolute. The earth buries, but it also exhumes. Wind and Thor reveal what they once hid, as if the planet occasionally reopens a page from its own long diary. What makes these buried records fascinating is not just what they show, but what they imply about our species. Civilizations rise where conditions allow. If climate changes, coastlines shift, or resources move, people adapt or disappear. But if such shifts have occurred repeatedly over hundreds of thousands of years, then our timeline of first civilizations may represent only the latest visible layer in a much older sequence. Each layer erased most of the last, leaving only hints for the next to rediscover. There's a quiet irony here. The more advanced we become, the more we realize how fragile knowledge is. Paper burns, metal corrodes. Digital data depends on electricity. Sand and ice, indifferent and slow, preserve what we can't. They become our unintentional libraries. Fossils, ruins, even imprints of bacteria endure longer than any monument of steel. When we study those records, we're not just learning about others. We're seeing how the Earth remembers better than we do. In Greenland, cores drilled from 2 meters of ice have revealed dust, ash, and isotopes that trace volcanic eruptions, solar storms, and climate changes going back hundreds of thousands of years. Each layer represents a season frozen data in perfect order. Reading them is like listening to the heartbeat of the planet over deep time. But between the stable rhythms, there are anomalies. Sudden spikes in temperature, mysterious chemical markers, and layers of ash whose origins remain uncertain. Some may correspond to asteroid impacts or massive fires. Others could represent events we don't yet recognize, disruptions large enough to reset ecosystems, perhaps even civilizations. If the Earth has endured many cycles of rise and collapse, then beneath every desert and glacier, there may be chapters of culture we'll never fully read. But the hints we do find, roads under dunes, stone terraces beneath waves, and geometric shadows under ice, suggest that intelligence has left its fingerprints again and again, each time wiped clean, each time beginning anew. Even in the most remote places, traces of human presence appear. Microplastics have reached the bottom of the Mariana Trench and the interior of Antarctic snow. If we vanish, those residues will remain as part of the next geological layer, our own faint signal to whoever comes after. The Earth will file us away with everything else, sealed under future sediments and ice. In that sense, we're already joining the archive. We study the notion of hidden civilizations beneath ice and sand that often attracts speculation. But the scientific principle behind it is straightforward. Visibility is not permanent. Most of human history lies where we cannot see. Archaeologists estimate that less than a small fraction of ancient sites have been found. The rest are buried, eroded, or submerged. The next major discoveries likely won't come from open excavation, but from deep scanning, drilling, and patient listening to what the ground itself can tell us. Perhaps what fascinates us about the idea of lost worlds under ice and sand is not just the mystery of the past, but the recognition of our own impermanence. The same processes that buried their cities will one day bury ours. The same dunes and glaciers that conceal their stories will in time write over ours. Yet just as their memory persists in myth and stone, ours will persist in data and debris. The medium changes. The message repeats. Every discovery, a fossilized footprint, a tool, a submerged wall, acts as a reminder that history is not a straight line, but a mosaic built layer by layer. Each era covers the last, but never entirely. There's always a fragment that survives, waiting to be rediscovered to trigger the next round of curiosity. Somewhere under the ice of Antarctica, under the dunes of the Sahara, and under the waves of forgotten coasts, the remains of earlier knowledge may still rest intact. Maybe it's nothing more than pottery and tools. Maybe it's something more, a technology so integrated with nature that we no longer recognize it as such. Either way, the record is there waiting. And when those traces finally come to light, when the next buried structure or fossilized tool is pulled from silence, it may not just add to our timeline. It may bend it, showing that progress and memory are not opposites, but partners in the long rhythm of Earth's story. Beneath ice and sand, the planet keeps its memories cool and dry, patient and quiet, until curiosity returns to ask again what it once knew. Beyond those frozen vaults and buried deserts lies another kind of record, one not stored in rock or ice, but in the very structure of the planet itself. The next layer of this exploration belongs to the world's own memory, the slow, vast system through which Earth records everything that has ever happened on its surface. The planet remembers everything. It does not do so deliberately, but through its own physics, through chemistry, temperature, and pressure. Every action, every climate, every movement leaves a trace somewhere. If you look closely enough, the Earth itself functions as one enormous time capsule, archiving every layer of its history beneath the thin skin of the present. The soil, the ice, the ocean floor, the magnetic field, all of them are records waiting to be read. We tend to think of archives as fragile human things, subject to decay. Yet the planet's archive is both fragile and eternal. It erases details and preserves patterns. It forgets names, but remembers consequences. This realization is relatively recent. For most of human history, we thought of Earth as static, a backdrop. It took geology to teach us that the ground itself is alive with memory. When scientists began drilling into ocean sediments and polar ice, they discovered that every sign's a year, sometimes even a season. Dust, ash, and tiny bubbles of air are trapped in these layers, forming a continuous chemical record of the atmosphere. Through these samples, we can reconstruct temperatures, volcanic eruptions, cosmic events, even solar radiation cycles going back hundreds of thousands of years. That precision has changed the way we understand time. The ice cores of Greenland and Antarctica hold the breath of the planet, literal air from ancient climates. When those bubbles are released and analyzed, they reveal fluctuations in carbon dioxide, methane, and oxygen, tracing not only natural cycles, but also human influence. The oldest of these cores reach back over 800,000 years, long before modern humans, showing patterns of warmth and cold, rise and fall. The repetition is unmistakable. Each warming phase brings expansion, each cooling retreat. The rhythm is planetary, but within it, we can now detect the faint fingerprints of civilization. In lake sediments, pollen grains settle year by year, recording the vegetation of entire eras. When the pollen changes abruptly, It signals shifts in temperature, rainfall, or human activity. Charcoal particles tell of fires often synchronized across continents. Oceanic cores record layers of microossils, each species tied to a specific climate condition. Together, these natural archives form a kind of planetary diary written in chemistry and biology. We're only beginning to learn how to read it fluently. But what's most intriguing is how selective this diary is. The Earth does not preserve everything equally. Organic materials vanish quickly. Metals corrode. Plastics break down over centuries, though traces will persist as microfragments for far longer. What lasts best are transformations, the chemical residues of events. A mass extinction leaves a layer rich in iridium. A volcanic eruption leaves ash infused with rare minerals. A nuclear test leaves isotopes detectable for millennia. The planet records change, not detail. If we apply that understanding backward, it becomes possible to search for traces of earlier civilizations, not through artifacts, but through chemistry. This is the essence of what scientists call the Silurian hypothesis. The idea that if an industrial society had existed millions of years ago, its primary evidence would be geochemical, not architectural. We would find anomalies in sediment layers, elevated carbon from fossil fuel combustion, synthetic compounds, or isotopic ratios inconsistent with natural processes. Some researchers have even identified curious blips in the geological record that could fit such patterns. Spikes in carbon, mysterious isotopes, thin layers of unusual minerals, though none yet prove anything beyond natural variation. Still, the concept reframes our search. Instead of asking where ancient technology might be buried, we ask whether the planet itself has already recorded its existence. If a civilization once rose and fell long before us, its cities and machines would be gone, but the environmental signature of its activity could remain. A sudden pulse of warmth in ancient sediments, a thin layer of synthetic molecules, or a magnetic anomaly could all be echoes of forgotten industry. The Earth may already have told that story. We simply haven't learned to recognize it. Magnetism provides another layer of memory. The planet's magnetic field has flipped many times throughout its history. When lava cools, iron-rich minerals within it align with the magnetic field, freezing its direction like tiny compass needles. By studying these patterns, geophysicists can reconstruct continental drift and ancient field reversals. It's a planetary recording system built into rock. Some reversals coincide with extinctions or climate shifts, though the link remains debated. Still, the magnetic archive reminds us that even the invisible forces around us carry memory. The Earth keeps track of its own orientation, its own heartbeat, and perhaps even the influence of cosmic events beyond our atmosphere. There are stranger records, too. Deep within the crust, radiation from natural uranium decays into distinct isotopes over predictable timescales. By measuring these ratios, scientists can date rocks billions of years old, but they can also detect anomalies. In Gabon, Africa, a uranium deposit discovered in the 1970s showed isotope ratios that suggested SUSTAINED nuclear reactions had occurred there naturally 2 billion years ago. It was a natural reactor operating in pulses for hundreds of thousands of years. The discovery stunned physicists. Nothing artificial was involved. Yet the phenomenon mirrored the function of human-built reactors. The planet on its own had achieved nuclear fission. The site now serves as a reminder that many things we consider unique to civilization can also emerge spontaneously in nature. This blurring between natural and artificial complicates our sense of evidence. If we did find a geochemical anomaly, how would we distinguish an ancient civilization from a planetary event? A large volcanic episode or asteroid impact could mimic the same chemical signals as industrial pollution. The only difference would be complexity, the presence of compounds that nature doesn't normally produce. So far, we haven't found any definitive traces, but we've barely scratched the surface of Earth's deep record. Most oceanic crust, where such evidence might lie, is constantly recycled by tectonics every 200 million years. The planet erases itself slowly, but thoroughly, and yet not completely. Diamonds carry carbon from the deep mantle, sometimes containing inclusions that predate life itself. Amber traps insects from prehistoric forests, preserving not just shape, but biochemistry. Ice seals air from vanished atmospheres. The Earth, without intention, has preserved moments of impossible antiquity. Each one is a message in its own medium, compressed and patient. When we consider these natural archives, a larger pattern emerges. The planet is both the author and the librarian of its own story. We, its most recent chapter, are learning how to read what it wrote long before we arrived. In doing so, we also begin to see how easily our own records could vanish. Our cities, built of concrete and steel, would crumble in tens of thousands of years. Our data stored in silicon would degrade in centuries. The lasting evidence of our existence will likely be the same as for any earlier civilization. Chemical, not cultural. A brief layer of altered atmosphere, a spike in carbon, a residue of synthetic molecules, and silence. That perspective changes how we see ourselves. It suggests that the true history of civilization may be cyclical not only in culture, but in geology. Each industrial phase, whether ours or another, leaves a trace which the planet folds into its sediments before beginning again. The record is cumulative, but discontinuous like pages scattered through a long book. Some pages are lost, others rewritten, but the themes repeat. There's another subtler archive too, one written not in stone, but in biology. DNA records, adaptation, environmental stress and mutation. Traces of ancient viruses remain in our genome. Fossils of infection that changed who we are. Similarly, if earlier intelligent life altered the biosphere, its effects might persist in unexpected ways. Unusual gene distributions, extinct lineages that appear abruptly and vanish without clear cause. Paleontology already shows such patterns, sudden bursts of diversity followed by collapse. They may represent environmental upheaval, but they could also mark moments when intelligence briefly appeared, changed the planet, and disappeared again. The idea seems vast, almost too large to hold in mind, that the planet itself might have hosted multiple epochs of awareness, each leaving only chemical shadows for the next to interpret. Yet the evidence, incomplete as it is, leaves space for the possibility. The Earth's own processes make such cycles inevitable. Life arises, evolves, transforms its environment, and is eventually reset by change. Each time memory grows a little deeper in the crust and the core. We often imagine time as a line moving forward, but geology teaches a different lesson. Time on Earth behaves like sediment. It accumulates, compresses, and folds back on itself. Ancient layers rise again through tectonic movement, bringing the path to the surface in pieces. In that sense, the planet's time capsule isn't buried. It's circulating. It constantly exchanges memory between deep and shallow, between what was and what is. Every time we dig, drill, or analyze, we're participating in that exchange. We're reading a few sentences from a book that never ends. We take samples from ice, soil, and rock, trying to reconstruct the shape of what's missing. And what we find is humbling. Not perfection, but persistence. The planet doesn't need to remember everything, because it knows that eventually someone will rediscover enough to begin again. That's what makes the study of these archives so powerful. It connects the scientific and the philosophical. When we study ice cores or magnetic reversals, we're not just collecting data. We're tracing the continuity of intelligence itself, whether human, ancient, or future. We're seeing how knowledge is stored not only in minds, but in materials. The planet is in its own slow way a teacher. It keeps the answers buried until we're ready to ask the questions correctly. When we listen to the ice, the sand, and the stone, we're not just hearing echoes of the past. We're hearing our potential reflected back. Every anomaly, Every unexplained pattern is an invitation to think wider, to consider that civilization may be a recurring feature of Earth's surface, one that leaves faint but recoverable imprints each time. The planet's memory isn't linear or local. It's distributed like a neural network, operating across continents and epochs. We are part of that network now, adding our own signal to the mix. And perhaps one day when the next species or civilization digs through our layer of the archive, they'll find just enough to recognize us. Not through our machines or monuments, but through the chemistry we left behind. They'll know that someone once understood the planet well enough to wonder whether it remembered. And by then we will have become another entry in the Earth's long, patient memory. One more sedimentary line in the time capsule of the planet. Beyond that archive, beyond the physical record of what the world has kept, lies another question that bridges imagination and evidence. If we did uncover the remnants of that earlier knowledge, tools, mechanisms, perhaps even functioning devices, what would we do with them? What would it mean to rediscover technology older than our species? And how would we interpret it? That question leads us toward the next layer of this story, where speculation and discovery meet. The quiet thought of what it would mean if we found their tools still waiting for us. Imagine the moment when the ground gives up something it has held for longer than memory. A tool, a fragment of metal, a structure too precise for its supposed age. At first, it would seem like an anomaly, a misdated object, an error in context, a coincidence of geology. But as more appear, each too advanced for its era, a pattern would start to form. We would realize that what we've uncovered isn't just an artifact, but inheritance. The discovery wouldn't just rewrite history. It would make us reconsider what we mean by civilization itself. If we ever found a tool undeniably older than known humanity, our first instinct would be skepticism. We test it, date it, examine its chemistry. We try to fit it within what we already understand, because the framework of science depends on continuity. But every major discovery in history has forced that framework to stretch. The first fossils that hinted at extinction, the first galaxies beyond our own, the first quantum experiments. Each began as an impossible observation. So too would an ancient technology that defies time. To imagine such a find, it helps to think about what kind of object could survive. Metal corrodes, wood decays, even stone erodes. The tools of an ancient civilization would have to be made of something durable enough to resist both time and pressure. Perhaps crystalline ceramic or mineral composites. Some natural materials already fit that description. Zircon crystals can survive billions of years. Synthetic versions of such materials could outlast continents. If an earlier species or culture achieved even a modest level of technological sophistication, it's possible they left behind objects that still exist, embedded deep within rock layers or ocean sediment, mistaken for geological formations. Occasionally, we encounter what scientists call out-of-place artifacts, objects that appear inconsistent with their surroundings. Most have rational explanations: intrusive burial, misidentification, contamination. Yet a few remain stubbornly ambiguous. Machined-looking stones from ancient strata, metallic spheres with balanced grooves, coal deposits containing what seem to be worked fragments. None have passed the rigorous standards of proof required to confirm artificial origin, but their existence keeps curiosity alive. They remind us that discovery often begins with anomalies that don't yet make sense. If a genuine artifact from a forgotten civilization were ever confirmed, the reaction would depend on its nature. A simple tool would raise questions about the timeline of intelligence. A complex mechanism, something with moving parts or encoded data, would change everything. It would prove that the story of technology doesn't begin with us. It would suggest that innovation might be a planetary phenomenon arising and disappearing in cycles. The anti-Torero mechanism found in the Mediterranean offers a glimpse of how such a revelation might unfold when it was first discovered, encrusted, and corroded. No one recognized it as a computer. It took decades of study and imaging to reveal its gears and purpose. Now we know it modeled the motions of the planets. Imagine something even older recovered from deeper strata. A device operating on principles we only partly understand. We might recognize its function immediately, or we might not. Its technology could be so integrated with natural systems that we mistake it for mineral or fossil. Our ability to recognize technology depends on familiarity. We look for shapes, symmetry, and patterns that resemble our own designs. But what if earlier intelligence used materials or logic beyond our comprehension? What if their machines were biological, or their data stored in crystalline lattice rather than circuits? We might walk past their artifacts without recognizing them. A piece of advanced machinery could look to us like a common stone, its internal structure invisible to casual examination. Only with new instruments might we notice the anomaly. A molecular arrangement too ordered to be natural or isotopic ratio, suggesting deliberate engineering. Even if we did recognize such a tool, interpretation would be complex. A device millions of years old would likely no longer function. Its energy source, if it had one, would be exhausted. Its purpose might be indecipherable. We might not even know whether it was practical, ceremonial, or formational. Yet the mere fact of its existence would carry meaning. It would show that intelligence capable of shaping matter with precision once existed here, and that we are not the first to do so. The emotional impact of such a discovery might be greater than the scientific one. It would challenge our sense of uniqueness, our narrative of progress. We often imagine ourselves as the culmination of evolution, the only species to cross a certain threshold of awareness. To learn that another civilization once reached similar or greater heights and was forgotten would shift our perspective profoundly. It would remind us that progress isn't destiny. It's an opportunity easily lost. If we did find tools or devices that still functioned, the implications would reach further still. A working mechanism would allow us to study materials, energy sources, and design principles we might never have conceived. It could revolutionize science or confound it. If the technology were sufficiently advanced, we might not even know how to turn it on. It could rely on principles outside our physics or interfaces we don't recognize. We might need to reverse engineer its context before we could even hypothesize its use. In that sense, the discovery would be as humbling as it would be inspiring. There's precedent for such humility. Many ancient inventions were misunderstood when first rediscovered. Concrete, for instance, was lost after Rome and reinvented centuries later. Greek fire, Damascus steel, and other lost technologies demonstrate how easily knowledge can vanish. Each rediscovery feels new, but in truth, it's a reawakening. The same could happen on a far grander scale if we ever unearth truly ancient machines. Our first step would likely be caution. The artifact would be isolated, scanned, and tested. Scientists would argue over authenticity and function. The public would speculate. Some would deny its possibility. Others would seek confirmation of old myths. Governments might withhold findings until analysis was complete, fearing social disruption. Eventually, though, the evidence would speak for itself. A device built millions of years ago, operating with precision and purpose, could not be ignored. It would raise immediate practical questions. Was the civilization that made it native to Earth or something else entirely? Were they like us biologically or something different? Did they leave voluntarily? Or were they erased by catastrophe? If they understood the planet well enough to build technology that survived geological ages, why did they disappear? The answers might lie within the artifact itself. It could contain information, encoded in a form we have yet to decode. Vibrations, magnetic fields, or arrangements of atoms functioning as data. Modern researchers are already exploring storage at atomic scales. Perhaps someone did it before. The idea may seem improbable, but it aligns with how knowledge behaves in the universe. Once a principle is discovered, flight, energy conversion, computation, it becomes available to any mind capable of understanding it. If life evolves intelligence multiple times, the same discoveries may recur in different eras. The tools may differ, but the logic stays constant. The wheel, the lever, the gear, the circuit, all are manifestations of physics. The same could be true for whatever comes next or whatever came before. Finding ancient technology would also alter how we approach our future. It would show that civilization can vanish completely, leaving only fragments. It would make us think differently about preservation, sustainability, and memory. We would understand that survival isn't just about progress. It's about redundancy, ensuring that knowledge endures even when the systems that support it collapse. There's a quiet lesson in the possibility of rediscovery. Each generation believes it's reaching unprecedented heights. Yet we keep finding evidence that earlier ones may have walked similar paths. The Antira mechanism, the precision stonework, the impossible maps, all hints that our story may be a repetition. If so, then progress isn't linear, but circular. Each cycle leaving traces for the next to interpret. Finding a tool from that previous loop would confirm the pattern. The artifact might not even need to be mechanical. It could be conceptual, a coded sequence, a mathematical constant, a message embedded in the natural world. Some have speculated that certain recurring ratios in physics, like the fine structure constant or the geometry of DNA, could themselves be remnants of design, natural laws adjusted or utilized by prior intelligence. If so, the entire planet might already be an engineered system, self-regulating and self-recording, a machine that outlasts its makers. We can't know until we look. And we are looking. Deep core drilling, deep sea exploration, planetary radar, and space probes are all part of the same effort to read the memory of the universe. Each time we find something unexpected, a geometric pattern on a distant moon, a magnetic anomaly under ice, we face the same question: natural or intentional? The line between them grows thinner as we learn more about how nature organizes itself. If the day ever comes when a piece of undeniable ancient technology is found, the challenge won't just be to study it, but to understand it philosophically. What does it mean for intelligence to reappear in cycles? Are we part of an ongoing experiment, or simply the current expression of nature's capacity for awareness? The answers might not diminish us. They might place us in context, one chapter in a planetary continuum of thinking matter. And yet perhaps the most profound discovery wouldn't be the tool itself, but the realization that we've already been surrounded by their work all along, that the world we inhabit is in some sense their legacy. The geometry of coastlines, the distribution of minerals, the rhythms of energy, all could be remnants of design so deeply integrated into geology that it now seems natural. If that were true, we would be studying not alien or ancient technology, but the infrastructure of the planet itself. Whether literal or metaphorical, the idea of finding such tools leads us back to reflection. What would we leave behind if the same fate befell us? What would the next civilization discover when it digs through our layer? The fragments of our technology, glass, silicon, alloys, will persist in some form, but the meaning will fade. Context will vanish, and what remains will look like mystery. Perhaps that's how the last world's tools appear to us now. Mute, contextless, waiting for us to notice. If we ever do notice, and we learn to read those remnants correctly, we may find that they're less about power and more about continuity. Tools, after all, are just extensions of thought. They're the bridge between mind and matter, between imagination and reality. Finding theirs would remind us that we're part of that same lineage. Not the beginning, but the continuation. And beyond that realization lies the final layer of this long story. The quiet awareness that everything we build, everything we remember, eventually becomes part of the same archive. The tools, the myths, the ruins, even the questions, all of them merge into the planet's collective memory. What remains is not the object itself, but the impulse that created it. And it's that impulse to know, to build, to remember, that links us to whoever came before. That continuity leads us into the last reflection. The idea that civilization itself, not just its artifacts, might be a form of memory. That what we call progress may simply be the planet recalling itself through us in cycles too vast for any single lifetime to perceive. Civilization is a kind of memory. It doesn't remember in the way a mind does with images or words, but through continuity. The shape of our cities, the design of our tools, the systems we build to organize life, all of it is a form of recollection. Each generation inherits fragments of understanding, refines them, and passes them on. What we call progress might simply be this collective remembering repeated over thousands of years. The tools change, the languages evolve, but the underlying drive stays constant to understand the world and to preserve that understanding long enough to share it. When we look at history through this lens, the rise and fall of civilizations resemble patterns of memory formation in the brain. There are bursts of innovation followed by periods of decay and loss, then recovery. Knowledge spreads, consolidates, and sometimes collapses, only to reappear in a different form. The memory never truly vanishes. It reorganizes itself, much like a neural network adapting to damage. The Earth might be hosting something similar on a planetary scale. Not a single mind, but a recurring awareness expressed through different species and societies, each remembering a little more than the last. Every civilization builds archives. Clay tablets, papyrus scrolls, digital clouds, different media, same impulse. The materials change, but the goal remains the same. To resist forgetting, yet forgetting is built into the system. Fires, floods, and wars erase records. Languages die. Scripts become unreadable. Each loss creates the illusion of beginning anew, but traces of the old persist quietly, embedded in the next iteration. Even when we think we've lost something completely, fragments remain in myth, in architecture, in unrecognized artifacts. The continuity of civilization is not clean, but it is resilient. If we imagine the planet as an organism, then civilization might be its memory organ, storing experience in cultural form. Human activity for all its chaos functions like a distributed intelligence, recording environmental data, creating feedback loops, modifying climate, and building structures that alter the planet's surface. The effects are measurable. Satellite images show networks of light wrapping around the continents, glowing like synapses. Data moves through cables under oceans, mirroring the transmission of signals in a nervous system. The comparison isn't metaphorical, it's structural. Civilization organizes matter and energy into patterns that process information. That process isn't unique to us. Termite mounds regulate temperature through architecture. Coral reefs build structures that store ecological memory. Forests communicate chemically through mycorrhizal networks, sharing resources and signals across miles. Each of these systems remembers in its own way what has worked before. Humanity is simply another layer, a faster, more reflective one. We record not only what we experience, but what we imagine. That's the difference between biological memory and cultural memory. Ours can include things that haven't happened yet. The problem, of course, is that memory is fragile. It depends on redundancy. The more copies that exist, the longer information lasts. Yet most of our knowledge now resides in digital form, ephemeral, dependent on electricity and infrastructure. If civilization were interrupted for even a few centuries, much of our accumulated data would vanish. Books and inscriptions might survive, but the vast archive of our era, the web of text, images, and code, would fade into unreadable dust. That realization connects us to the very civilizations we study. We worry about forgetting because we've seen it happen before. Perhaps that's why ancient builders favored stone and symbols. They encoded knowledge in durable forms, aware that only materials resistant to time would carry meaning forward. Geometry, proportion, and orientation served as mnemonic devices. Even if the language was lost, the pattern would remain. A pyramid aligned to the stars still communicates its builder's awareness, even when their words are gone. The memory survives through structure, not speech. Our modern monuments, data centers, satellites, and machines serve the same purpose, though less durably. They store knowledge in layers of abstraction. Magnetic fields on disks, electric charges in transistors, optical pulses in fibers. These are fragile compared to stone, but they multiply fast enough to maintain themselves. Civilization now replicates its memory faster than it can lose it. Yet speed doesn't guarantee permanence. The faster information moves, the shorter its lifespan tends to be. Digital memory is vast, but it's volatile. Without power, it fades. It's possible that earlier civilizations faced the same problem in different forms. They might have relied on materials or systems that seemed permanent, but weren't. Over tens of thousands of years, even the most sophisticated technology can erode into invisibility. The few traces that do survive become myth. The stories of gods bringing fire, of lost golden ages, of knowledge descending from the sky. These may be echoes of that fading memory. The transmission continues, but the medium changes. Each generation, without realizing it, reconstructs part of the same story. We rediscover geometry, astronomy, medicine, and energy. The same ideas were refined and renamed. It's not that we start from nothing. We start from what the Earth allows us to remember. Climate, resources, and curiosity set the boundaries. When conditions align, civilization blooms again. The patterns of trade, governance, and architecture return almost instinctively, as though they were written into the collective code of humanity. That repetition may not be a coincidence. It may be recalled. Even myth behaves like a long-term memory system. The details distort, but the essence persists. Catastrophe and renewal, fall and rebirth. These cycles describe not just morality, but the mechanics of history. Civilizations rarely disappear without trace. They transform into the next. Mesopotamian ideas shaped Greek thought, which shaped modern science. Egyptian architecture influenced Roman engineering, which inspired the design of cathedrals and skyscrapers. Each layer reinterprets the one before. What we call innovation is often rediscovery through a new perspective. If earlier civilizations existed and vanished, they may still be influencing us indirectly through environmental inheritance. Minerals extracted, climates altered, even genetic adaptations could carry their signatures. We wouldn't recognize them as cultural memories, but as background conditions, the starting parameters for our own rise. The planet in that sense could be guiding our development through accumulated history, ensuring continuity even across extinction. It's strange to think that memory could exist without awareness, but that's what nature does constantly. A glacier records temperature without knowing it. A seed carries genetic instructions without intention. Civilization extends that principle to consciousness, the ability to remember deliberately. But even deliberate memory can become unconscious when transmitted over long enough time. Myths, rituals, and architecture preserve behavior that no one remembers inventing. We repeat them because they feel right, not because we know why. That intuitive continuity may be how planetary memory sustains itself, not through deliberate preservation, but through habit encoded in culture. If this is true, then what we're doing now, studying the past, recording, speculating, is part of the same mechanism. We are the planet recalling itself. Our fascination with lost civilizations may not come from curiosity alone, but from recognition. Something in us responds to those ruins and myths because we are in a sense remembering. The unease we feel when we encounter precision too advanced for its time, or maps too accurate for their age, may be the echo of that recognition. The mind identifies its own reflection in an older form. The continuity of memory also explains why progress feels exponential. Each cycle builds upon remnants of the last, even when unacknowledged. Knowledge accumulates faster than it decays. Once a concept reappears, it's reestablished permanently. We will never forget the fire again. We never lose mathematics entirely. Each rediscovery strengthens the planetary archive. Eventually, the layers of memory overlap, creating stability, a threshold beyond which total amnesia becomes impossible. Perhaps we're approaching that threshold now. Even so, impermanence remains a constant. Civilizations may grow more connected, but they also become more vulnerable to systemic failure. A global network can collapse faster than an isolated culture. The memory of civilization to endure must therefore diversify, embedded in multiple forms: biological, digital, material, symbolic. The more ways knowledge exists, the more likely it is to survive. Ancient builders seemed to understand this intuitively. They encoded information in art, language, and geometry. We do the same with code, genetics, and simulation. Different tools, same purpose. There is a certain humility in recognizing that we are participants in a long relay of memory rather than its culmination. It shifts our focus from dominance to stewardship. Instead of asking how much we can build, we begin to ask how much we can preserve. Not just for ourselves, but for whoever comes next. The planet has a way of selecting what it keeps. It favors the meaningful, the resilient, the adaptable. If civilization itself is a memory process, our role is to add coherence to it, not noise. Somewhere in the future, if another species or generation digs through our remains, they'll interpret us as we interpret those before us. They'll find traces of our architecture, our tools, our myths. They'll notice patterns of energy use, chemical residues, orbital debris. They may wonder what drove us: curiosity, survival, or the same impulse they now feel. And in that recognition, the memory of civilization will continue. We often speak of knowledge as power, but it might be more accurate to call it continuity. Power fades quickly. Continuity lasts. A civilization that understands how to remember itself, even through loss, effectively becomes immortal in fragments. The fragments are enough. They accumulate until the next awakening, when someone again learns to read the planet and hear its story. Perhaps that's the real legacy of the first civilization. Not their tools or monuments, but the method of remembering through pattern, sound, and story. Every rediscovery, every scientific insight, every structure aligned to the stars may be a reactivation of that original memory. We may never know their names or languages, but their influence endures in the questions we keep asking. The memory of civilization isn't static, it's recursive. It loops through time, rewriting itself while preserving its essence. Each version becomes the teacher for the next. We are both the students and the scribes, maintaining the continuity of awareness that the earth seems determined to keep alive. And in that continuity lies a kind of peace, the knowledge that forgetting is never absolute. That even when history collapses, the memory beneath it waits patiently to return. If we could step back far enough to see all of time at once, the rise and fall of civilizations would look less like separate events and more like a single pulse, a long, steady rhythm of remembering. The planet breathes in discovery and exhales loss again and again. We are living in one inhalation, contributing to a memory that began long before us and will continue long after. And somewhere deep beneath the surface, under ice, sand, and stone, the traces of those who remembered before still rest. They are not gone. They're waiting. Their work is preserved by the same planet that now holds ours. When the time is right, when curiosity aligns with patience, the next seekers will find what we have left. Our echoes, our maps, our questions. And through them, civilization will remember once more.